Assalamu alaikum everybody. How are you all doing? Am I audible? Kindly let me know. Can you guys hear me? Let me set up the chat box in front of me to get all the live messages. Assalamu alaikum everybody. By the way, my bad. So yeah. Yeah, I know. I turned it off. You would be able to hear me now. Give me a second. That's great. That's great. How is everybody doing? Ready for a crazy session? Inshallah, we're gonna have a really good session today. The plan is to basically first cover up the topic number 3, which we were discussing yesterday, and then afterwards, we're gonna jump towards discussing some concepts related to topic number 1 and topic number 2, especially in regards to some practice question. I guess so. It's fine though, but if the webcam is lagging, that's gonna get fixed. Okay, don't worry, that's gonna get fixed because it's due to this software issue. But once we start the streaming, that problem will be solved. How long is the session going to be? Let's see, but most probably around 2 hours something. So 2 hours 10 minutes, 2 hours 20 minutes, or whatever, right? So we're gonna be jumping into it directly at sharp 10 p.m. I don't want to waste any more time. I'm just waiting for everybody to join in so that we can start off towards 10 or 10, 10, 20, 10 or 2, 10 or 3, and then like in 2 different channels. No, it's just because the webcam is lagging, but just a minute, that would be fixed in a while, okay? So, let's start off. So you guys would be able to see the screen. We will be starting off with this part from here today, inshallah. I'm going to ensure that it goes perfectly fine and that we cover up this topic in great detail, and then after that ensure that if there are any questions we also address those and then move on. So just give me a minute, let me send this link in one other group, and then if you guys want to share it with your friends, you can, because we're going to start off in like 2 to 3 minutes. So if anybody wants to join in, they could just directly come up. So yeah, CIES. Sir, do you see my messages? Ayan Fawad, yes, I see your messages. Walaikum assalam, Mustafa. How long is the stream going to be? It's going to be of 2 hours something, okay? So the plan is to first and foremost start off with the content of chapter number 3. Okay, we're gonna cover, we're gonna do everything, even the network hardware, everything. Okay, we're gonna first cover up chapter number 3. It was almost done though, but a bit of it was left. So 3.3 and 3.4, they were basically left. So we're gonna cover these two parts first, and once done with those, we're gonna then move on towards doing some topical questions from chapter number 1, where my main focus is going to be on file size calculation. There has been a lot of problems with students saying that, sir, how will we do those complex large sort of file size calculation questions and all that stuff. And then we're going to move on to chapter number 2. Ayan bhai, if 2 hours plus is a lot, then you tell me how can we cover up the content. You also have to practice it a lot, okay? How do we cope up with the forgetting curve? That's a really good question. But in order to do that, what do we call it? The thing which needs to be basically brought into action is that you start doing topicals. Okay, the more you do topicals, the better you're going to be performing. So the more topicals you solve, the purpose of doing these topicals up here is to ensure that you guys recover any point which you might forget. Okay. So again, the class we held before 10 o'clock, basically my schedule is really packed up. So for that reason, I just get time around this 10 p.m. But I'm gonna try, maybe we can have a class tomorrow at around we can have a class tomorrow of 4 to 6. Sir, do a 4-hour live stream. Bro, should I just wait, man? I'm also a human. How can I do a 4-hour live stream? That's gonna be really challenging. Alright, it's like 10:01. Let's then just start off with the concept. As for tomorrow's class, we can have a discussion over that later on. So yeah, and yeah, inshallah 2 hour would be enough to practice almost the difficult questions. Okay, apart from this, you guys could go and practice on your own. It's not that you should just do this and you would be fine. This is just to ensure that if any concept has been forgotten, you can recap that concept from this class, and then after that you should just grind those topicals. Yep, you should do 2023 onwards topicals. And let's start off with Bismillah Rahman Rahim. So it's 10:01 p.m. Let's start off. And that day, perhaps yesterday, we ended our class having this discussion over senses, which was the very last thing we studied. Today we're going to start off from the senses part with the introduction into the topic of data storage. So what's data storage? Data storage was basically a unit introduced in your syllabus to cater towards discussing how you can store data, how you can store applications, how you can store files. I'm going to discuss all this later on. Okay, so how you can store data, how you can store applications, and how you can store files. Now that's pretty much very basic introduction, and the purpose of this live stream is to just quickly take you through everything so that if anything is being forgotten, you can recap it. For that reason, I'm just going to skim through the least important part and we'll be only focusing on stuff that is important. So in your syllabus there are only two types of memories. Okay, one type is known as the primary memory and the second one is known as the secondary memory. So your primary memory, it's that type of memory which we say is the most important type of memory. It is the one which is directly accessible by your CPU, or is the one which with which the CPU can directly communicate. So for instance, something like RAM, something like ROM, something like cache memory. We studied cache memory yesterday. If you remember, cache memory was discussed when we were saying that if I want to increase the performance or improve the performance, we said that to improve the performance of a computer, I can have a memory which is even more faster than RAM because it could directly communicate with the CPU at a faster pace. That was my cache memory, right? So RAM, ROM, and cache memory. These are three types of my primary memory which are in our syllabus. Now for all of you, the main points here to memorize is that what are primary memory? What is primary memory? What are their characteristics? What are their features? Okay. So remember that primary memory's very first feature is that it is directly accessible by your CPU. Whereas the second feature is that it is volatile, especially for RAM, which means that data is not stored permanently. We even studied this yesterday when discussing the part of RAM, that RAM stores the data which is currently being executed. For that reason, whenever you're going to see the marking schemes, you're always going to see that they write the word RAM followed by the word volatile. Why do they call RAM to be a volatile state? Walaikum assalam. The reason they call RAM to be volatile is that the term volatile basically means that it's not going to have the data permanently, at least in the world of computer science. When I say that some memory unit is volatile, this means that the moment I turn it off or I take out the power or I, let's say, shut it down and return it on, everything within it is going to be deleted. So RAM is your primary storage, which is basically volatile. We're going to discuss this inshallah in more detail too, but for now just remember 2 points. Primary memory is that memory which is directly accessible by your CPU, and it is the stuff which basically includes data related to your computer system working. So like for instance, it includes data which is currently being executed, it includes data which is used for your computer to boot up, and it includes data which is frequently being used. We're going to discuss all of these 3 points inshallah in more detail over time. Alright, on the other hand, we have something known as a secondary memory. What's secondary memory? Secondary memory is basically that type of memory which is not directly accessible by the CPU. It is also non-volatile, and it could be both internal and external. What do I mean by this? So point number 1 means that, let's say if I want to have my CPU directly talk to some secondary memory, that is not possible. My CPU would be like, okay buddy, I don't have the direct WhatsApp number of the secondary memory so that I can communicate with it. They do not have their frequency being matched up, right? So for that reason, whenever we want to run something, we take something from the secondary memory, which is what? Which is my hard disk, which is my SSD, which is anything of that nature, and we bring that into my RAM for it to then communicate with the CPU. Then secondly, remember that your secondary memory is basically non-volatile. When I say that something is non-volatile, this basically means that it has the data stored permanently. So if I say that something is non-volatile, this basically means that it has the data stored inside it permanently. Whereas if I say that something is volatile, this means that the data is not stored inside it permanently. And of course, we saw that primary memory includes stuff such as RAM, ROM, or cache memory. And of course, all of these three things are usually inside the computer. You never find them outside, like you never connect a RAM externally, right? Whereas when we talk about secondary memory, they could be internal and external. Now, secondary memory have these examples. They have removable hard drive, which could be anything like removable hard disk, removable SSD, anything which is external. Your USB or flash memory disks, your Blu-ray disks, your DVD CDs, DVD RAM, and of course these hard drive also includes such as if I have a hard disk within my computer, a SSD within my computer, and so on. Okay, and likewise, or perhaps this was in terms if it was external, and if I have to talk about the device secondary storage which is within my computer, stuff like hard disk or SSD, they come under the secondary storage part. Whereas when I talk about the primary memory usually only consists upon RAM and ROM. So generally remember that your RAM stores the data which is currently being executed. Okay, any data which I currently need to basically run or execute or process, that data is going to be stored in RAM. Whereas the ROM is basically that type of primary memory which basically stores my boot up information. So when I say that it stores my boot up information, by the fact that I mean boot up information, this basically means that, okay, you all would be aware, right? My computer does not have a built-in Windows installed inside it. I install it as a software. Now when you press that power on button, what loads that window? Right, definitely window is also an operating system. It's not like you press that power on button and the window loads. No, it's basically you press the power button and then it calls something known as a bootstrap or a bootloader, and this is something which is stored inside your ROM. This thing then basically loads your operating system. And this bootstrap material, or the BIOS, you also call it BIOS, that is basically stored within the ROM. Okay, so we're going to discuss all this inshallah in more detail too. But yeah, why is ROM non-volatile? Because ROM consists, we're going to come to this point later on. Okay, we're going to come to this later on and then we're going to discuss this in great detail, don't worry. So coming to the first type of the primary memory in our syllabus, which is RAM, we have two types of RAMs in our syllabus. The first one is known as DRAM, which has the full name or form of dynamic RAM, whereas the second one is the SRAM. SRAM basically stands for static RAM. Now the general features for both the SRAM and DRAM are that data can be written to or read from, and data can be changed by the user, which basically means that, okay, we have RAM could have data coming in, it could have data going out. So like let's say I want to play RDR2, so Red Dead Redemption 2 data, because I want to execute it right now, they come into RAM. The moment I'm done with it, I might want to remove it because I now want to play Fortnite. So the RAM gets empty, and now again I load up Fortnite files, and then the Fortnite files are coming in. So this means that RAM is specific type of memory which could have the data being changed, it could read, it could write, and it could have the data being manipulated again and again and again. The second point is that your RAM basically stores data that is currently in use. We studied this even yesterday. And the third point is that it is volatile. When I say it is volatile, this means that the moment your PC or any computer hardware, it loses its power and it turns off. The games, the files, everything which were turned off or which were within your RAM, they are turned off. So the point here to note is that the term volatile basically is the reason why when you're playing Fortnite on your computer, and thanks to Pakistan, when the light goes out, or like when you're playing on your laptop but your battery runs out and your computer is turned off, the next time you reopen it up, the Fortnite game is not at this point where you left it. It's like the computer started all the way from the very beginning. Why? Because whatever was being executed at that point, that data was stored inside RAM, and RAM is basically volatile. And because RAM is volatile, this means that the moment it gets turned off, everything is going to be deleted. Now remember that dynamic RAM is that type of RAM. You just need to know a general information about it. It's not that much detailed, and also it's just for your own understanding. According to the syllabus point of view, this might not be even tested, but still you should be clear upon it. Okay, dynamic RAM consists of multiple transistors and capacitors. So a transistor is like a switch. Okay, so you basically have multiple switch. The switch basically allows whether the value needs to be changed or whether it needs to be read or blah blah blah. So like if I say that the data stored in a capacitor is something like 0, there is going to be a switch. The switch can convert it into a 1, and if I have something like 1, it could change it into a 0. So what happens is that your RAM works in a way that basically due to multiple combinations of these switches, they basically hold your information in terms of zeros and ones. Okay, but remember that this dynamic RAM is that type of RAM which needs to be constantly refreshed. Why? Because it has a capacitor. A capacitor is a component, electrical component, which basically holds charge. Okay, so any electrical component has this one characteristic, that if I want to give it some charge, I need to re-give it the charge again and again, otherwise it's going to lose the charge. And because in our case the charge is basically 0 and 1, which is my binary, if I lose the charge, this basically means I'm losing my zeros and ones. That's the reason why when your power goes out and your charge vanishes, because there is no more power coming up, everything in the RAM gets deleted. So now it might make sense to you, right? So you should know that when we talk about dynamic RAM, for your own understanding, because it has capacitors inside it, it needs to be consecutively refreshed to ensure that the data within it is not lost at all. Okay, moving on, the second type of RAM in our syllabus is known as the static RAM. Now the static RAM is basically that type of RAM which basically does not need to be refreshed. They make use of a different technology which is known as flip-flops. What they are, not in your syllabus. Again, even the static RAM, again, it's not that important, but still you should be clear upon it. Okay, just one point here to note is that SRAMs, which are by static RAM, they are way more faster than DRAMs, which are the dynamic RAM. Why? Because they make use of the flip-flop model. Okay, flip-flop model. How much did we cover? We just started off like literally 10 minutes ago, so we haven't covered anything. So RAMs, which are static, they basically are way more faster. And now here is the point why I'm discussing this with you. We have something known as cache memory in our syllabus, right? But we don't know what cache memory is. Just know that cache memory is basically a type of SRAM. Okay, that's the reason why we say that cache memory is something which is even more faster than the normal RAM. Why? Because it's basically the static RAM one which makes use of flip-flops, and because it makes use of flip-flops, it has even a more faster performance than a normal RAM. Now if I have to discuss the differences between them, the differences between DRAM and SRAM are pretty much straightforward. The DRAM one basically consists of number of transistors and capacitors, whereas the SRAM one uses flip-flops to hold each bit of memory. Your DRAM needs to be consecutively refreshed, whereas your SRAM doesn't need to be consecutively refreshed. Yeah, I know it's not in our syllabus. It's just to tell you guys so that you know the general point, okay, for the understanding of the topic, so that you know that when we talk about cache memory is basically a type of SRAM, okay? Then you should know that DRAM is less expensive to manufacture than SRAM, and that's also the reason why if ever in exam they ask you why is cache memory not used that frequently. Now up here you should know that cache memory is an SRAM, so you should tell them that cache memory is basically not used because it's way more expensive to manufacture, okay? And then it has a faster data access time. Again, CPU memory cache makes use of SRAM, we know that. And DRAM basically is constructed, the main memory which we have in our computer, that's constructed from DRAM, and it consumes less power than SRAM. So the main point of discussing both DRAM and SRAM is to ensure that you understand when a question is being tested for cache memory, you know that cache memory is a type of SRAM, and that all these characteristics basically are talking about the cache memory part. Okay, so it's better to have some general information about it, because if a question comes up in exam, then bro, you cannot take that risk at that point. It's just exactly as Romo Studies just said, that better be safe than sorry. Alright, let's move on. The second type of primary memory in our syllabus is known as ROM. ROM stands for read-only memory. Remember that in RAM, we know that RAM is specific thing where data goes in. Okay, it goes into my RAM, and then afterward it gets empty, and then again data again goes inside it, right? And then goes again and again and again. But ROM is that type of memory which can only be accessed and cannot be written into. Walaikum assalam. So if you have a type of memory which cannot be accessed but could only be read, that is what we call as ROM. So ROM, it's that type of memory which stores data related to the powering on of the computer. And whenever we talk about powering on of the computer, we are referring to something known as BIOS. And what's BIOS? BIOS basically stands for Basic Input Output System. Or you can also say bootstrap, which is another formal word, which basically is the startup instructions, which in simple words would also mean, what are the steps to power on a computer? Power on a computer. That's it. So your ROM basically stores the data related to powering on of the computer. But remember, ROM is a permanent memory, which means that data could neither be added inside it nor removed. Whatever the manufacturer created, the way manufacturer basically what do we call it, whatever the manufacturer created and whatever they added inside it, that has to basically stay. You cannot sort of change that part. If you did, you won't be able to load up your computer. For that reason, what they did was they basically ensured that it is something which is inaccessible, and for that we say that ROM is basically non-volatile. By saying that non-volatile, this means that it has been a primary memory which can only be read, but the data inside it can neither be deleted and it cannot be added. Is this clear, everybody? Alright, let's move on. So RAM and ROM have basically two differences. RAM is temporary memory device, ROM on the other end is a permanent memory device. RAM is volatile, ROM is non-volatile. RAM could be written to and also at the same time read from, whereas ROM is something in which the data cannot be altered. RAM is something where you can store data, you can store files, you can store programs, you can store part of operating systems, and of course if you want you can even increase the RAM. We all know, right? If I have 16 GB in my MacBook right now, by the way you cannot do it for MacBook though, but if I had, let's say, a gaming computer, I can change it to a 32 GB one. Okay, that's pretty much doable. But ROM is something which only stores the data related to BIOS and other stuff which is required to boot up your PC. So you cannot increase the ROM, okay, because it's only created to store that specific set of instructions which are required to boot up your PC. Let's move on. Sir, is BIOS and starting of software in our syllabus? Yep, it is. So now comes up a few applications of where RAM and ROM could be used. I'm just going to discuss one of the examples. So like let's say we have an example of RC car, okay? So an RC car could have the example of ROM in terms of storing the factory settings, such as like when you turn on the car, this frequency from the remote controller, or like how do I need to turn on, maybe it has some specific routines to follow. By routines I mean that let's say it might play some sound, it might on some light or something of that nature. So if it has to execute anything whenever you try to turn it on, you need to store all that instruction in ROM, and all these instructions within the ROM are stored by your manufacturer, so you have to do nothing. It has been set by the person who created that device. Whereas RAM in the other end is something where if I want to add something of my own, maybe my own instruction, maybe something on my own, I can basically add that inside it. Okay, so the RAM will basically store the data, the instruction which are received from the remote control unit. Clear? Let's move on. So that marks the end of our primary memory. Now we're going to discuss the secondary memory one. Just give me 1 second though. I need to make one change up here. Otherwise guys, I'm going to answer all of the questions. I'm not sort of ignoring anybody. It's just that a lot of questions are coming up, so it's not pretty much doable to answer all of them. But don't worry, I'm going to discuss all of them, okay? So let me just take a few questions. So Mujtaba, where is your question? I'm unable to find it. Mujtaba, can you resend your question? Thank you. A, B, C, D, E, F, G, A. What's your question? Walaikum assalam. Alright, so I see that you guys don't want to study, just want to come up with fake IDs. Well, if that's your intention, then good luck, because on the result day, you should also come up on my stream there, and inshallah on that day I'm going to ask you whether you got those A's or whether you are preparing for retake. Okay, so do let me know if you're someone who wants to enjoy this thing. So what's the difference between RAM and cache? The only difference is that cache memory is operated using SRAM, which means that it is even way more faster. Okay, it's even way more faster. But the problem with cache memory is that it is smaller in size, whereas your normal RAM, it is a bit slower, but it has a larger size, and it's basically the dynamic RAM. Now coming to the secondary memory topic, we have three types of secondary memory. One is known as the magnetic. When we talk about magnetic, we have discussion about hard disk. Okay, then we have the solid storage, which includes stuff like SSD, SD cards, flash drives. When we talk about flash drives, we basically talk about the USBs or the pen drives we have. Okay, and finally we have the optical media, which basically includes stuff like CDs, DVDs, Blu-ray discs, and all that stuff. Now coming to the first type, which is the magnetic one, Magnetic storage is that type of storage in which the data is stored on magnetic surfaces of platters. So we basically have such a circular disk, okay? It has such a circular disk, and in that disk what happens is that we divide it into tracks and sectors. So we make tracks, okay, this is a track, and we make sectors. And all these tracks and sectors, you can assume them that, let's say this one track is like, for example, this is like one folder, okay, this is one folder. So all the data about one thing will be coming in this one line. And let's say this entire sector is one large drive. So like you might have local disk C. So I can say this is my local disk C, and inside this on my tracks I'm basically storing the data. So if a question comes up, when will we do the past papers? Once we are done with this, okay, don't worry. So if a question comes up upon magnetic storage, you should know that what happens is that because the data is stored on magnetic surfaces, we have multiple platters which are consecutively spinning. So this whole thing spins again and again, the way we can see up here. This is a hard disk. So this thing rotates, okay, very fastly. And while it is rotating, what happens is that we have an electromagnet at the top. So this device, and this electromagnet basically reads the values and either reads it or writes the data. How does it do that? That's something which makes use of which they make use of using magnetism concepts, but that is not in your syllabus. You should not be aware of it. Just know that we have an electromagnet writing head at the top, which basically is used to read the data and at the same time write the data. So just know that if ever in exam they ask you about magnetic storage, know that the magnetic storage is like a circular disk where the data is stored on magnetic surfaces, okay, and that surfaces is divided into sectors and track. A sector is basically a part of hard drive that have a fixed amount of bytes. So like if I say that one specific drive of 10 GB, and then track is basically something which stores the actual data within it. So like out of this one 10 GB file, we have like a one folder which has all my essays. So the data is stored in the track, whereas the file, the large area where the file is stored, like the local disk, the disk which we usually have in computers, that's my sector. And the way it works is that this platter, they again and again spin very fastly, and then we have basically a read head up here attached at the top. You can also see like this device, and using magnetism properties, it is then going to apply some physics concepts which allows it to read the values of 0 and 1. And using those zeros and 1, it then evaluates the data and then maybe processes it later on. Okay, so one point here to note is, an important point here to note is that whenever you make use of the magnetic one or hard disk, they have a very big performance issue. The performance issue is that they have a large level of latency, lag or delay, which means that if I, let's say, have a drive or a file up here, let's say up here in this specific track, and let's say my read write head is going all the way from this and then it's coming to this point. So you're sort of waiting this entire time doing nothing, right? Because the disk is rotating. Because it's rotating and the head is just at one point trying to read it up, so it's just going to wait till this data comes beneath this and then it's going to read it. For that reason, we say that it has a large level of performance issue where you need to consecutively wait for the data block to rotate to the head, and this basically means that there's going to be a large level of delay, which we don't want. And second problem with magnetic device drivers is that it has the fragmentation errors, where what happens is that if, for instance, I give you an example, let's say we had some file up here, okay? So for instance, I was playing Fortnite, so this entire data was about Fortnite, okay? And perhaps, or rather than Fortnite, we can also say, let's say, let's assume that, okay, this was Fortnite till this point, and then we had something like the next file next to it was Red Dead Redemption 2, okay? So now if this was occupied, the red one is the Red Dead Redemption 2 and the blue one is Fortnite. But now let's say if I uninstall Fortnite from my computer, so by uninstalling, this means that the data occupied up here, that's going to be deleted, right? So this data gets deleted. But the problem is that when you do this part which has been removed, that part is no longer accessible. Why? Because your computer works in a way that it always moves the next side, okay? So it always moves to the next part. So now any new data will be basically stored up here rather than at the backward side, and this basically ensures that if the data is being stored, we have empty slots left. So if we have empty slots left, that's a problem for me because I'm not fully utilizing the space which I have on my hard drive, and that is something which we call as fragmentation, which is a big error because these non non-adjacent sectors, they basically collect over time, which basically means that if I have to now find this file which I just added, the black one, and let's say this has to come all the way from this all the way to this point for it to be read, right, this black part. But now if let's say there was a model where this part was empty and I could have added the black one thingy up here, it would have been easier for it to read it, and it would have also taken less time in correspondence to the other one. So I say that because this fragmentation error occurs, and this is basically what's fragmentation, it's when the adjacent sectors, non-adjacent sectors, they collect over time. So like if I say that I have deleted something, so one comes up here, then we have something empty, you cannot have anything at this point. Why? Because this part was deleted, and then you have data next to it. Okay, so this one part is empty, it has nothing inside it, and it's just going to increase my time, and that's a big problem for me. So how do we fix fragmentation? For that we have a defragmentation software, which is being something discussed in chapter number 4. And of course, if anybody wants to understand fragmentation or any of these concepts in further more detail, open up my YouTube channel. By the way, you guys are even watching it live, so Code Catalyst, go to the playlist section and watch the playlist for chapter number 3. It has everything in great detail. Perhaps my all-time favorite game was Hitman, by the way. Nothing better than Hitman. Okay, so yeah, will they ask us to draw this? I haven't seen anything like that in exams as of now. When I open up an app while I'm working on it, जो background में खुला है app का data, that is in RAM. Yes, it is in RAM. Whatever जो background में खुला है, or everything which is currently open, that is in RAM. But जो चीज़ आप अभी use करें ना, the app which you have turned open at this point, that app is then within the CIR. So whatever you are currently executing, that's within the CIR, और बाकी जो data open है, that's in the RAM. We even discussed this last night. Alright, perfect. So are the sectors in the magnetic storage divided into categories like stuff? No. It's like something like you would have seen that when you have a computer, whenever you want to install an operating system, you can on your own divide it into tracks. Like, okay, I want to create 5 drives. So you can create 5 drives of, let's say, 50 GB each. So you could have local disk A, local disk B, local disk C, local disk D, local disk E. So all that stuff. Okay. So what is firmware? Firmware is the boot up instruction. So similar to the bootstrap which we studied earlier on. When will we do chapter 3 topicals? We're going to do chapter 3 topicals tomorrow, inshallah. Alright, moving on. Then we have the solid state drive. When will we move on to chapter 1? So ideally we're going to move to the topicals by around 11 PM, inshallah. Okay, so yeah, now what are solid state? Now the biggest benefit we get when we make use of solid state drive is that they do not have any moving parts. When they do not have any sort of moving parts, exactly, these are like the local disk drives, exactly. So solid state one do not have moving parts, which means that you do not need to rotate again and again, move here and there, and the magnetism would have to be applied, nothing of that nature. And because none of that has to happen, the best point is that we're gonna have no latency at all, because there is no rotation. No latency due to rotation, and because there is no latency or lag or delay due to rotation, I say that my SSD is faster. And that's the reason why you say that SSD has a better performance. It's not like the SSD has some unique sort of logic to it. It's just that SSD has this feature where SSD has no moving parts, so it gives you a better performance because there's not need to rotate. Why they do not need to rotate? Because rather than magnetic properties, they make use of flash memories, which they make use of NAND or NOR chips, which are again similar to what we studied in the RAM part, where they are like floating gates. They are like switches, in simple words. Okay, they are switches, and these switches are used alongside components which store charges. So they could store a charge of 0, which means no charge, and 1 where it could have charge. So again, just like before, we are going to say that these switches, they in computer science are known as transistors. So I say transistors are used as floating gate and control gate. Again, this much great logic is not required, but you should just know one thing, that according to the syllabus, it's stated that solid state memory, they make use of NAND or NOR technology, and that transistors are used as control gates and floating gates, including this example. Now the way it happens is that we have basically gates. Okay, we have gates, and these gates could have a value. So I'm going to say that this transistor, the transistors are sort of like these, you can say segments, and in these segments, thanks to the NAND or NOR chips, we could either store a 0 or we could store a 1. We could either store a 0 or we could store a 1, and based upon that, it's going to then store the binary value of 0 1 0 1 1 0 1 0 and so on, whatever binary value it is. So yep, it is in the syllabus. You can have a look at it up here. Okay, So if I have to quickly give you a recap, the way it works is that they have no moving parts. We have NAND and NOR chips, and what happens is that we have a control gate, okay, control gate, and then we have basically something known as the floating gate, okay, then we have a floating gate. Now the moment you basically put in the charge basically goes in, and that basically is surrounded within the floating gate up here. You can see the electrons are basically kept up here. So when electrons are kept up here, I say that the control gate basically prevents them from moving out. And if the charge is stored within a transistor, if I say that within the transistor the charge is stored, then I say that it represents the value of 1. And let's say it does not store any charge, then it's going to have the value of 0. Again, this whole logic is not something which you need to understand in great detail. The only thing you need to understand here is that solid state makes use of NAND and NOR chips, and the way NAND and NOR chips work is that they have floating gates inside them and control gates. These floating gates and control gates allows electrons to move in and out, which allows them to in turn store charges, and based upon these charges they can basically create the binary value. So if it has a charge, it's going to have the value 1. If it does not have a charge, it's going to be 0. So doing this for all the circuits will create some binary value like this. That's the whole logic. So this thing is not something which could be tested. Only point here to note is that we have NAND NOR chips which store charges thanks to the transistors, which basically make use of floating gate and control gates, which allow you to basically allow the electrons to move in and out, and based upon this we can store the charges where 0 could be no charge and 1 could be a charge. Alright, so let's move on. So if you are supposed to not actually learn these, for example, then why do they explain so much in our books? A good question, because your book was created by a person who wanted you to understand the concept. Okay, so like if you don't understand this logic, will you understand what does a control gate do or what does a floating gate do? Now this won't be tested in exam explicitly asking you about what a control or floating gate might be doing. For you, it's important you just keep it in your mind that they allow the electron to move in and out, and basically the control gate ensures that the electron stays within it, whereas the floating gate ensures that the electron are within it, right? You see electrons within them, whereas the control gates allow them to either move in or move out. But like if none of them were in the syllabus, you would have not understood a lot of concepts. So like the book has clearly mentioned at multiple places that all this stuff which is there in the book, they have been just included to complete the content, so that if a student reads it, he understands everything which is there in the syllabus, but it's not necessarily something which will be tested. Okay, so the data is in the form of electron, and after passing the so electron on its own is an electric charge. If it has an electric charge inside it, which means that electricity goes inside it, which means electron goes inside it. If an electron goes inside it, this means it has charge. It has charge inside it. So whenever it has charge inside it, it's 1. And when I say it has no charge, which means it is empty, let's say it has no electrons inside it, then I say there is no charge, so it has the value of 0. Clear? Perfect. Let's move on. Joseph, I have answered your question. Okay, so our optical storage uses bits and we're going to come to that. Okay, don't worry. So what are the advantages of SSD over hard disk? So the advantages you get for making use of SSD or hard disk is that SSD is more reliable. Why? Because it has a lower latency. It is way more lighter, and hence it's more suitable for laptops and phones. This point is really important because a lot of times a question comes up asking about why and where can an SSD be used. Let's say they give you an example of creating a phone company, and then you need to explain that okay, you should go with SSD because it's more lighter and hence more suitable for phones. Then of course it has an instant operation, which means that it's way more faster, of course, because it's something which is lighter, which does not require a lot of power, does not rotate a lot. We can also say that it consumes less power, which means that it is running cooler and it has an improved battery life too. And of course the best part is that it has the faster data access. Hard disk is magnetic. Yep. Yeah. Good boy CW2FG, you can watch yesterday recording, we discussed this in great detail. Now as for the drawbacks are that SSDs are way more expensive than hard disks. Okay, and then the second drawback is that every SSD has a specific limit. Okay, every SSD has a specific limit. The limit is that okay, we're gonna say that I created this component which works very fast, but this has a specific maximum value to which it can work. It cannot work more than that life capacity. So while creating a SSD, you need to create it of a specific read-write capacity. So I'm going to say that okay, there is this SSD which can maximum do like let's say 30 GB for example, okay, per day. So if you do more than 30 GB, it's going to stop working. Okay, so it's gonna stop working. So that's one drawback you get in comparison to the normal hard disk which you have, because if you have an SSD, it has a maximum read write capacity which an SSD cannot cross, but computer engineers are rapidly working upon them and then they're improving it. But that's the reason, because it has a maximum read write capacity, SSDs are not suitable for heavy read write operations such as in servers. So like these servers which we have for these large companies, the servers are always hard disk, they're never SSD. Why? Because SSD has a limit, hard disk does not have that one limit. So we have a question that how is hard disk SSD more reliable? So it's more reliable because your hard disk has moving parts. Okay, they have moving part. When something has moving parts, the moment you disturb the moving part somehow, it's no longer going to work. For instance, if I, let's say, have for example, this, let's assume, is my hard disk. Okay, this is my hard disk. If this is my hard disk and I, let's say, I have it in my laptop and I, let's say, take it a bit and I drop it, okay, so I drop it. So if my hard disk gets dropped, it's gonna basically ensure that the moving parts within them, those are disturbed. And if my moving parts are disturbed, the biggest problem is that it's no longer going to work. That's the reason any laptop having hard disk, if you lift it a bit and you drop it, it's the hard disk is going to fail. Why? Because the moving parts have been disturbed. So it's not reliable, because definitely all these devices, there is a great chance that I drop it at some point mistakenly. Okay, so to prevent that, if we have an SSD, now if this was an SSD and I drop it even from this point, it's going to cost nothing for us. It's going to still working perfectly fine because it has no moving parts at all. So HDD has the largest storage capacity than SSD. That was a point valid till the pre-2023 syllabus, but according to the newer syllabus, I would say that you shouldn't write this, because we have SSDs which have a high amount of capacity too. So we're going to start the questions at 11. Okay, so how do we have to study the only everybody asking about input output device. The stream for yesterday has been uploaded. Just open that stream, go to the input output devices part. I have explained it in super great detail as to what you need to prepare and what not. Okay, moving on, the third type of storage in our syllabus is the optical storage. When we talk about optical storage, we need to talk about CDs, DVDs, Blu-ray discs. And the way they work is that we're going to first and foremost discuss the CDs and DVDs. CDs and DVDs work in a way where the disc, they are like the data, it's basically stored on a metal alloy layer. So like this circular disc which we see, something like this is basically a thin metal alloy layer which has a light sensitive organic layer upon it. So this has a light sensitive dye layer upon it, and when laser is basically shown onto it, it basically reflects the data in a way where I can either read it or I can write data onto it. Now the way this happens is that this disc, it has basically spiral track which starts from the very center and it goes around. Now when you put that CD or DVD, whether into your console or you want to put that CD or DVD into your, what do we call it, computer or into your laptop or whatsoever, this, your DVD reader basically has something known as an optical head. Just the way we saw that for a hard disk, we have a magnetic head. For an optical storage media, you have an optical head. Okay, this optical head allows the data to be read. So it follows the track. So we have a head up here when you insert it into the computer, and that head basically reads whenever whatever data is coming onto it. So it's going to read that stuff and it's going to convert it into binary. Okay, it's going to convert it into binary, and everything which is happening up here, that data is then going to be stored in terms of bits and lands. So if I have to, okay guys, just a minute, let me quickly re-explain it. So the moment what happens is that we have a circular disc. Okay, we have a circular disc. The circular disc is something which is created of a metal alloy. Okay, it has a metal alloy. It has a dye onto it, so like it has a colored dye upon it, and that colored dye basically reflects. So when you want to read it up, you throw laser on it, and that laser allows your data to be read or maybe written. So like if I want to write some of, like let's say I purchased a CD which is of Hitman 3, and I, let's say, want to now play this game, I plug this, I put this into my Xbox. Okay, so now my Xbox has this DVD is inserted into it, but now what happens is that there's a magnetic read write head which basically throws laser, and based upon that laser, whatever data is on the DVD, it basically reads that data and then it processes that data. But now the point is that how is the data stored on the DVD? So like we have this circular disc, how is the data stored on this? So on your DVD, the data is stored in terms of bits and lands. What are bits and lands? We're going to come to that. But all the data is stored either in bits or in lands over this spiral circular track, and whenever I want to read the data, I'm going to make use of a red laser which is being thrown through the optical head. Now we have two types of CDs. One is known as the CDR. The CDR basically stands for write once. So if you have a CDR, this basically means that the first time you purchase it, you're basically just going to put the data, and then you can no longer add it up. So like the normal CDs we have for games, you cannot add data inside it. Okay, you just store data inside it and then you'll be good to go. The second one is CDRW. What is RW? RW basically means rewrite many times. By rewrite many times, I mean that it works similar to USB. You have a CD which you put in, you can execute it, you take it out, you might want to delete the data, you want to bring it another data, you can do it. So CDR is the one which is write once, CDRW is the one which you can rewrite many times. Now I have seen a question on CDRW pre-2023, that's the reason why I even taught it up here, but in the latest syllabus after 2023, I haven't seen a question upon this. Okay, coming to another point, when I mentioned this pits and lands, what do we mean by this? So by pits and lands, the way it works is that if I have this circular disc, if I, let's say, make it like just the way you can see on the screen like this, okay, something like this, pits and lands are something like when we have a normal DVD or a CD, if I have to basically convert this circular one into flat form, it's going to be something like this. Now whenever I want to write data on it, like whenever I want to store data inside the CD, whenever I want to store data inside it, I'm going to basically burn the DVD using red laser. Okay, so I'm going to burn the DVD using red laser, and when I want to burn it up, I won't be burning it at all the places. I'm going to burn it at specific places. What are those places? How? Where? That's not in your syllabus. Just know that we're going to shine the red laser onto it and it's going to burn some parts. So it might burn it up here, it might burn it up here, it might burn it up here, and it might burn it up here. So all those places where we are sort of burning it up, it's going to form something like this. So the other part is going to go normally, but the part which has been burned, it has a lower bump inside it. This bump part, which we say that this is basically my pits, and this part which has us flat surface the way we had previously, that's my lands. So you can even see this in this example that the burnt part is my pits and the normal part is my lands. Now when this the optical head, when it is reading the data, it looks onto the pits and lands. Wherever it detects a pits, it understands that okay, some data was stored up here, so it might count it as 1. And wherever it detects a land, it might count it as a 0. So based upon that, using the difference of pits and lands, it's going to convert the whole structure into 0 and 1. And of course, then my computer can easily understand what zeros and ones are. Yeah, we will, inshallah, don't worry, okay? So that is how your basically CDs works using pits and lands. Now when you talk about CDR has this problem that when you burn something using laser, once the pits have been burned, you cannot undo that, right? So anything which makes use of pits and lands, that is write once, which means that the first time you burn it with data, which means that you permanently store the data inside it. Why? Because the pits have been burnt, and for that reason you can then say that your data is stored permanently, and then you can no longer add data again. Can these bumps be reversed? No, you cannot. Okay, that's the reason why I'm saying that for the CDR, it's going to be only write once. For the CDRW, then it's going to make use of different logic, but that's not the pits and land one, and you aren't required to think about that. सर पेपर लीक होते होने तो टाइम क्यों ज़ाया करूँ मैं? गोश्त रशर भाई, पेपर कोई लीक नहीं हो रहा. ओके गाइस, इजी सीन है. कैम्ब्रिज एक्सेप्ट ही नहीं करेगा, डोंट वरी. So imagine you are not preparing for your exam, and the way we saw it for chemistry, chemistry. Okay, we saw that for chemistry students they were like, okay यार leak हो रहा है यार, easy scene है यार, Netflix देख देता हूँ, Netflix करता हूँ यार, अभी कोई सीरियल देखता हूँ, सही है, easy scene है, अभी तो शोल करेंगे, वैसे भी तो पेपर कैंसिल ही हो जाने, क्या मसला है. And the next day the questions were not the one which were there in the leak paper. So you're going to get heavily scammed, and I'm telling you, paper number 1 is the marks gaining paper. Okay, you don't want to lose marks up here. I'm conducting these back to back marathons for a reason. Okay, I'm conducting them so that you guys can learn. Anybody who is dedicated can stay. For anyone who is not interested in taking the class, for anybody who just wants to say कि यार मुझे नहीं चाहिए, मैं सो जाऊँ, guys, you can leave the class. Okay, easy scene है. I'm not forcing you to take the class. सीखना है तो इंसानों की तरह आराम से बैठ के सीख लो, नहीं सीखना तो टाटा बाय बाय, नेटफ्लिक्स खोलो, रिजल्ट के दिन पे खुद पता लग जाएगा. Okay, so if you do your hard work, I'm telling you one thing, I don't know anything else. If you put in your hard work and you have trust in Allah, I promise that you're gonna get a good grade. I promise nothing can stop you from getting a good grade, inshallah, if you have trust in Allah and you have trust on your own hard work. I'm telling you. Okay, so just give it your best and you'll be good to go. Moving on, the second type is basically DVDs. Now, what's the difference between CDs and DVDs? So it's sort of similar to CDs. It's sort of similar to CD-RW perhaps, but the thing is DVDs basically have a higher capacity than CDs. How do they have a higher capacity? So what happens is that they take two CDs, so like CD1, CD2, and they join the two together, and boom, the newer one which we have, that's my DVD. And in between they add a thin reflector to allow the data to be read from the two CDs. I even made this example up here, that let's say this is CD number 1, this is CD number 2, and then in between we have a thin reflector which once you join in, you're gonna form something like this. So if one CD was of 500 MB, the other was of 500 MB, so I get something of 1000 MB, which is 1 GB. So just like that, you basically create a DVD. It makes use of dual layering, which is just this concept where you join two CDs together, and what happens is that these two separate layers, they are basically separated using a transparent spacer and a thin reflector. Why do we make use of thin reflector? Because if we just join the two together, how will I ensure that this is a part of this? Like, how can this and this work together? It needs to ensure that the data could be reflected here and there too, right? So that we can interconnect them. So for that we have this thin reflector in between them. Another point is that if I have to create a DVD which is only read once, write once, if it's a write once DVD, then remember that it's going to have a smaller bit size. And if it has a smaller bit size and a track width basically refers to, again, track width is not in your syllabus though, but again, the same track width, this distance, okay? But if it has this smaller distance and it has a smaller bit size, track width, yeah, so you see these track runs. So like if this distance is reduced and the bit size is also reduced, this basically allows more data to be stored. And of course the third point is that whenever you make use of DVD is basically made using a laser with lower wavelength. So we have a point up here, is one point that any laser which has, or any optical storage which is being created with a laser of lower wavelength, that's going to have a higher capacity. So the lower the wavelength, the greater the capacity it can store. So for instance, if CDs have a wavelength of 780 nanometer, it could store up to, like, let's say 4 GB. If DVDs have a wavelength of 650 nanometer, it's less than 780. It might be able to store up to, let's say, 16 GB. And then we have Blu-ray, which has even lower wavelength of the laser, and that allows it to even store GB's file like 40 to 100 GB. So you should keep this in your mind. That the lower the wavelength, the greater the capacity. Again, these wavelengths are not to be memorized, but yeah, that's the logic. Okay, let's move on. So what is a DVD? Good question. Move on. Sir, I only have an overview of how to memorize topicals. Okay, guest paper. Buddy, you tell me one thing. 10 to 11 questions are going to be tested in your exam, okay, for paper number 1, 10 to 11. 6 topics hai. Wouldn't this mean that every single topic is going to be tested? There is nothing like a guest paper, at least for computer science, okay? It's like literally just fake stuff. There is nothing like it. It's just going to be like every possible content could be tested, okay? So don't worry. Sir, are the drawbacks and benefits of optical camera are the drawbacks and benefits? Grim Reaper, I did not get your question. Sir, I don't see any question on this in recent past paper. Yes, there haven't been a question, but again, you cannot take the risk. If there is something in the syllabus, they might ask it, right? Sir, average marks for paper 1 is, so if I have to focus upon for the A grade is round about uh, almost anywhere between 44 to 50. So I have the average A grade I have seen is around 44 to 46. Or perhaps, yeah, 44 to 46, which means that an A star would be anywhere between 54 to 57, given that you also at the same time do the same for paper number 2. Okay, so सर बाकी अंदर 3.3 कमज़ोर हो तो इजी सीन है. Easy सीन तो नहीं है, बट हाँ कवर अप कर लो. It won't take you that long. Okay, just watch these 2 sessions and you'll be good to go. बस इतना भी पता you're fine. But yeah, Blu-ray discs. Now, what is Blu-ray disc? It's the third type of optical storage. What happens is, I'm going to send the topicals, don't worry, okay? The differences from the CDs and DVDs is that Blu-ray disc, they basically make use of blue laser rather than the red one. Because blue laser has a smaller wavelength than the red one, which, like for instance, blue one has 405 nanometer. It has a very great capacity. And because it has a very great capacity, I can also say that it's going to have even smaller pits and lands, which is going to further increase the storage capacity. So I now know that when I decrease the pits and land size and when I decrease the wavelength of a laser, it's eventually going to give me a larger capacity size. Now there are 2 types of Blu-ray discs. One is the single layer one, where everything is stored in a single DVD, so like 1.2 millimeter single disc. And then the second one is where you join 2 discs separately of 0.6 millimeter, and then you basically combine them again using a transparent layer in between, and this allows you to have a greater storage capacity. One point here to note is that your Blu-ray discs, they have a security element inside it, which means that they have a built-in encryption system. When I talk about built-in encryption system, this basically means that you would have seen, let's say one of you just go and buy FIFA 19 DVD, okay, a Blu-ray game, okay, for let's say PS5. Okay, now if you want to copy that up, why can you not copy it? Like, why isn't it not possible that I just buy it once, I put it into my computer, I copy it up, and then I put it in my USB and play it on my console? Why isn't that possible? It's because my game has been securely encrypted, which can only run on my console, which might be PS5. Apart from that, it won't work. So it's thanks to this Blu-ray encryption system, it's even way more secure, and it prevents piracy. What is piracy? These fake softwares which we try to crack and use. Okay, so here's a table which basically gives you a sort of overview of it. You don't have to memorize any of the stuff which has been highlighted in yellow color, but yeah, this just gives you an idea of what's happening. Okay, yeah, so all right, so should we now start topicals? We're gonna just cover up chapter 3 and uske baad topicals. Okay, so ho jayega, don't worry. I'm gonna give you guys a small break of 5 minutes before we start topicals. Don't worry. So now we're going to discuss virtual memory. What is virtual memory? Virtual memory is like, for instance, one of you wants to play FIFA. And when you want to play FIFA 20, the problem is the moment you want to run the game requires 7 GB of RAM. It requires 7 GB of RAM. But the problem is that our computer has a RAM of 6 GB. Now, this means that if my RAM is of 6 GB, but I want to play a game of 7 GB, then I don't have the space to play it, right? I don't have the space, which means that I'm cooked, because my computer will be like, from where can I bring that 1 GB data? From where can I bring that 1 GB data? So in that regards, whenever we have a problem like this, we have a concept known as virtual memory, where what we can do is that this hard disk which we have, which is even though a bit slower, but still what I can do is that I can create a sort of a RAM, virtual RAM within the hard disk. So I can use the hard disk space to create invisible sort of RAM within the hard disk, and then my CPU can basically communicate with that, and this could then allow me to have extra data, and thus I can then play FIFA. So for instance, remember that physical memory which we have is always RAM. Virtual memory is the one where you have the RAM plus you have some hard disk and SSD help to create some invisible extra RAM. For instance, if I see up here, if I have to basically run a operation which requires 2.4 GB, but the maximum I have is of 2 GB. What I can do is that the remaining 400 or 0.4 GB space which I need to execute this 0.4 GB, what I can basically do is I can tell my hard disk that, hard disk bro, come up, make a small space for me of 400 memory, so that any data which is being coming up, I can bring that empty data or like data inside this, so my computer does not crash. And that's the reason which we stated up here. Why do we bring up the virtual memory topic? to basically prevent your computer from crashing when more memory is required. So if I require 5 GB but I only have 4 GB, if I am unable to do it and I'm unable to provide the RAM, it's gonna crash. So what I can do is that the 1 GB RAM which I have extra, this 1 GB RAM could be taken up from my hard disk or from my SSD. So the way it works is, I'm gonna come to that point, Kiran, don't worry. The way it works is, rather than explaining it from here, I'm going to explain it up here for you all so that you better understand it. So the way virtual memory generally operates is that you first and foremost have RAM. Okay, this is my RAM. RAM at one point, let's say, could only do 3 tasks. Okay, it could only do 3 tasks. But you are someone who wants to do 5 tasks. And then I have, because I know that it cannot get filled into RAM, I create a virtual memory which can then store extra tasks. So what we do is that whatever data I'm currently executing, whatever I'm currently doing, the one which I need the most importance. Why? The one which I need the most important, the current executing thing, that is going to be stored in the RAM. Like RAM would include, let's say I'm opening up my notes taking app, I would have Google, Chrome, I would have, let's say, my streaming software open up. All those things are opened up. But now let's say I also have WhatsApp open up, so I can basically have WhatsApp opened up. I have Zoom open up, let's say. So those are also open, but they are something which are working in the background. Okay, they are working in the background. So if something is working in the background, this means that I don't need its immediate attention. I don't need to put all of my power into processing them. So what we do is that this virtual memory, that is basically slower, because we know that this hard disk, it is very slower when I want to access it from the CPU. So for that reason, the process works in a way that whatever I want to execute at this point, whatever is the stuff which needs my immediate attention, which I need to do right now, that stuff is basically brought up from my computer hardware into RAM. So it's in the RAM. So because my RAM and CPU can have a faster communication, I can say that they basically execute it quickly. And anything which is being running in the background, which I'm currently not working upon, that thing basically goes into my virtual memory, which is slower, because even though I'm not processing it, I don't want it to turn off. I'm saying like, okay, let it be processed, but I don't want it to be turned off, and I don't want it to be immediately processed. For that reason, we bring it in this invisible memory for it to not get stopped and not get crashed. But at the same time, whatever I'm currently doing, that's going to be in the RAM. Now for instance, now I want to open up WhatsApp and I no longer need the Google Chrome. So what I can do is that in a concept where I want to basically open something else which needs more attention, what happens is that whatever data you want to basically swap, you're going to copy the stuff which you want to run right now from the RAM into your ROM, and from the your virtual memory, and whatever you have in your virtual memory, that's going to go up there. So we had basically Fortnite, right? So I'm going to say Fortnite is basically going to come up here, and let's say we had Google, so that Google is going to come up here. So now this thing is not required for me, so it goes into my invisible memory because I'm no longer accessing it, whereas whatever I'm trying to access at this point, that goes into my RAM. So this process of whatever I currently need that stays in the RAM is known as swapping, where whatever you need at this point, whatever you're currently executing, that data goes into RAM, and whatever you don't need, that goes into virtual memory. Then when the stuff which you need from the virtual memory, when you want to bring that into RAM, and the stuff which you have in the RAM which you no longer require, and you take that into virtual memory, this swapping of data is known as swapping. Clear? I don't even get a little pseudocode. Grim Reaper, I have a solution for you. Open up my channel, go to the playlist section, watch chapter number 7, chapter number 8 playlist, watch some chapter 9, chapter 10 videos on your own, and then after that watch the marathon videos which I have uploaded for paper number 2, and of course after that, from inshallah the 14th till the 17th, we're going to do 15 marker sessions too, so you're going to be very much good to go. So exactly, the stuff is consecutively swapped in and out based upon whatever I'm trying to do right now, and that is what's happening up here. So whatever I need currently, anything which I need to immediately work upon, that data is stored in my RAM. Whatever I know that okay, I don't need to work upon Microsoft Word at this point, that is stored in the virtual memory. Then later on, when I want to, let's say, open up Microsoft Word and I no longer require the Insta, so this Insta is replaced up here and I no longer require it, that goes into my virtual memory because I don't want to close it. I want it open but I don't want to use it, right? Whereas my Microsoft Word, which I'm currently using, that's going to come up here. So that's the whole process of how this process works. Now, point here to note is that this data moving here and there, like you take Insta from this part, you bring it into the virtual memory, you take this Microsoft Word from here, you bring it up here, and like this entire data going here and there, here and there, here and there. In this, there is a component known as paging. You know, there's a component known as paging, which basically is the swapping of fixed size block of data pages between hard disk and RAM. So like the data going from hard disk into my RAM, when the data goes from hard disk into my RAM, whether that's of Instagram, whether that's of Microsoft Word, the data transfers in a process known as paging. And every data that is being transmitted, that is basically known as a page. So a page is basically a block of data, okay, and the process in which that is being transmitted, that is known as paging. Okay, the benefits of virtual memory is that it allows programs larger than RAM to be run. It allows the computer to do stuff without getting crashed. It allows you to prevent wasting data on unused RAM. So like if I have space in the RAM, which let's say I'm very low on RAM, okay, I'm low on RAM, but the problem is I'm low on RAM and the scenario is that there is something which I don't require. So what I do is, thanks to virtual memory, the stuff which I don't need, I take that into my virtual memory part, and then I have data for stuff which is required at this point. And the last benefit is that because you have virtual memory, you sort of do not need the to purchase any extra RAM. However, this point is still vague. Why? Because this virtual memory has a lot of drawbacks, that it's very much slow. So you cannot expect to have unlimited RAM that you say that okay, I'm going to create 100 GB RAM. The performance is like literally so worse. Okay, so worse. But yeah, but then there is one point in this, that let's say while swapping the data, where I say that okay, Google goes there, Fortnite comes up here, OBS goes there, Zoom comes here, notes going up here, here and there. When the data is consecutively transmitted here and there, just a minute guys, give me a second. Yeah, so whenever you're consecutively transferring data here and there, 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 there's gonna be a point where your computer will be like, bus, stop, I can no longer do this. Why is this person making me his slave? And that point is known as disk thrashing. At that point, when you have a large amount of read write activity where your data is just going here and there without any sort of actual processing, your CPU never gets the chance to process anything, because the data comes in, the data goes out, the data comes in, the data goes out, the data comes in, the data goes out, and this results in something known as disk thrashing. When this happens, your computer crashes, and the point at which the computer crashes, that is known as thrash point, and that marks the end of our virtual memory. Moving on, we have something known as cloud storage. Now, what's cloud storage? It's a platform where the data is stored on remote server and is managed by hosting companies. So you sort of store storage on some external places, okay, digitally. You don't have the space. Like if I have 2 terabyte at this point, I have like 5 terabyte, mashallah. But like if I have to store the data somewhere, like if I store 5 terabyte worth of data somewhere, it's not stored on my computer, right? It's not stored on my computer, but it is stored somewhere remotely. So when you get this platform where the data is stored on a remote server, which is then managed by hosting companies, that concept is known as cloud storage. Now there are 3 types of cloud storage, but because we are short on time, I'm not going to discuss this. Why? Because these are not in syllabus, okay? Not in syllabus, but they were just for the purpose of completing the content, so I'm going to just skip them up. But yeah, this is really important. What are the benefits and drawbacks? A question can come up on this, okay? So I have I have the pro version for like the entire year. So yeah, save my exams. Okay, save my exam notes free. Back then when I was appearing, Save My Exams did not even have the computer science notes. But yeah, so let's move on. So what are the benefits? So the benefits of using cloud storage is that definitely you can access your data anywhere, wherever you have internet. Then the second benefit is that you're no longer required to carry any external storage device because everything is online. Why will I be carrying a hard disk or a USB with me? Everything is available online. Then definitely the data could also be remotely backed up. So maybe if my data gets lost from my laptop, I might still have it in my iCloud, okay, or in my Google Photos. So that prevents data loss. And then of course, if someone's hard disk fails, they can still have recovery. And the best part is that if I currently have 5 TB, I can even extend this to 25 TB. So I sort of have an unlimited storage capacity, which is really important. Sir, can you skip stuff? No, you cannot. You cannot. Okay, what are the drawbacks? The drawbacks are then definitely if you don't have an internet, then boom, you're cooked because you cannot access your data anywhere without internet. The second one is that even though you might think that okay, I have storage, the cost is very high. Okay, like if you want to get something like 20 TB storage, that's going to be very expensive because you're not only going to pay for the cost, you're also going to pay for the data going downloaded and uploading, and so you're like paying a lot of money. And then there is also this one big problem that what if your remote servers fail? So God forbids if the servers somehow fail up, then boom, all the data is going to be deleted. So cloud storage has this one big risk that the data could be lost. And basically to prevent this scenario where the data is lost from all the servers, the clients or the people who provide this cloud storage facility, they basically make use of data redundancy. What is data redundancy? Data redundancy basically is the concept where they store the data on multiple servers to ensure that the reliability is improved. But then of course we have a few concerns to it too. The concerns are that definitely you might not have control over it. Anyone having, if you're using Google's remote servers, Google can definitely access your data. So any confidential data can be accessed by the cloud providers. Then of course if the server gets hacked or the data gets deleted somehow because the remote servers fail, then in that case you could also have a potential data loss. That is also a big problem. And that marks the end of our chapter number 3.3. We're going to do topicals. Don't worry Fawad, we're going to do it. Sir, virtual memory is ineffective in the long run. It's ineffective when you want a large amount of virtual memory. So if you want just a small chunk of virtual memory, that's perfectly fine. But if you want a very large chunk of virtual memory, that's going to be a problem. Well, I guess Mother's Day is tomorrow at like 10th. It's the 10th of May. Alright, let's also cover up network hardware, and then I'm going to give you a 5 minutes break. Then we're going to come back and do topicals. So network hardware is chapter number 3.4, and this basically discusses how you connect to the internet. So you should understand that every computer, everything which can connect to a data, which can connect to an internet using Wi-Fi, it basically has a network interface card inside it, which basically has a short form of NIC, and it is that component which allows your device to connect with the internet. Okay, so this NIC, when you bring and connect this NIC to your computer, it is usually within it, it basically has a MAC address. So this MAC address is basically assigned to you by the NIC. And what's a MAC address? MAC address is that unique address that uniquely identifies your device over a network. So like if I have 10 computers in front of me, if I want to uniquely identify a specific computer, that will be uniquely identified using your MAC address. And your MAC address is basically in this format where it has 6 groups, and every group has 2 pairs, where the first 3 groups, they basically have the manufacturer code, and the later 3 groups basically have the device code. For example, this is like a MAC address in front of you of a company, of an Apple device, where like this first 6 digits, or the first 3 groups, group number 1, group number 2, group number 3, they tell us the manufacturer code. So this is a manufacturer code for Apple, whereas this is the manufacturer code for some device. So now this basically tells me, when I look up at the the manufacturer ID, I get to know that okay, this is an Apple device and this is the device number. So this basically allows us to make distinctions and all that stuff. So we have 2 types of MAC address. Again, this isn't something tested that much, but still you should be aware of it generally. MAC address 1 is the universally administered. This is the one which has been set by the company. Okay, it is something which comes alongside the NIC, and it is something which you never change. So this is that MAC address which your company sets for you. So like all of our devices have a UAA MAC address, but then there are a few exceptions where, let's say, you want to access or do something specific where there is some restriction on the specific MAC address set by your company. by your company, so, or by your country. Okay, so in that case you can also create a MAC address on your own, which is known as LAA, which is the locally administered address, and this is the MAC address which is set by the user, or like the custom MAC address. And when you create a local administered address, this overrides your UAA. But the thing is, it has a high risk that it's not unique, and if it's not unique, then there will be a lot of problems, because if data is being sent to your computer and then there are two devices with the same MAC address, the network will not be able to understand where to send the data. And now, why should one go with local area network, local area administered MAC address over the universal one? It's just that the local one, they bypass the set requirement of like a strict MAC address format. The local one can also bypass routers and firewalls, and it could also pass certain types of network restriction. Just keep these points in your mind. I haven't seen a question on this ever, but still it is something you should understand. Second part of chapter number 3.4 is IP address. What is IP address? It stands for Internet Protocol Address, and this uniquely identifies your device on a network, which means that every device connected to a specific network, again, people usually do not distinguish between MAC address and IP address. Okay, the main difference between IP address and MAC address is that IP address is a unique identification number assigned to every device connected to a network. So if I connect to one PTCL device, and in this PTCL device I have one console connected, one PC connected, one laptop, and one mobile, all of these four will be having a unique IP address, but that IP address only stays within the network. So if like I go out and I connect to my friend's PTCL network using my phone, my IP address is going to change. So my IP address is going to change. Why? Because IP address is a unique identification number which is assigned to every device, but it is something which is assigned when you connect to a network. So you can say that your CNIC is something like MAC, like your national identity card number, right? It's MAC. So whenever you have your device, you take it to your friend's home, you take it to your own home, you take it to your school, every time the MAC address is always going to stay the same. But your whereas your IP address is always going to change based upon the internet you connect to or the network you get connected to. So a simple example was that, okay, you might be in one house. So inside that house, whatever room number you sit in, so I can say maybe I one day sit in room number 1, the next day I sit in room number 2, the next day I sit in room number 3. So similarly, a person like me, I have my name Mars. So Mars is my MAC address. This never changes even if I go to my friend's home, right? It stays the same. But if I go to a specific room, and then I move to the next room, and then I move to the next room, if someone asks for where Mars is, the room number can always vary, right? But the name Mars always stays the same. So remember, the name or like this MAC address is always going to stay the same. It's always going to uniquely identify your device over the entire world. Okay, it's never going to change. Whereas your IP address is a unique identification number which is assigned to every device which is connected to a network. And what does this IP address do? They are important because when you want to send data, like let's say you're downloading something, so something is downloaded, it comes to your router, and now your router has to see where to send it, right? So it's going to distinguish based upon your IP address and based upon the MAC address, and it's then going to make a decision, okay, this data needs to go to the laptop. So it's going to bring this data from the internet and it's going to reroute it to the laptop. Okay, so IP addresses are really important because they have a specific set of rules which needs to be followed by a network, and a specific set of rules which needs to be followed, that's known as protocols. Okay, so in our syllabus there is two types of IP addresses. One is known as the IP version 4, which is IPv4, and then the second one is basically known as the IP version 6, which is IPv6. Now IPv4 makes use of 32 bits, and it makes use of this period to distinguish between them. So like 192.168.100.1, the normal PTCL one which we have. But the problem is that because it has only 32 bits, it can have a maximum capacity of 2 raised to power 32 bits, which is very less given that we have a lot of devices. So because we had a lot of devices, computer scientists were like, okay, let's go on and create something new. So they created the version 6 of IP address, which now makes use of 128 bits. Now this has even larger possible combination because now you have 2 raised to power 128 possible combination. That's so great. And now if a question asks you for the difference between IPv4 and IPv6, remember, IPv4 makes 32 bits, IPv6 makes 128 bits use. IPv4 makes use of a period to distinguish between them, and IPv6 makes use of colon to distinguish between them. And IPv4 basically does not make use of hexadecimal, and IPv6 makes use of hexadecimal. An IPv4 basically only has 4 groups, and IPv6 usually has 8 groups. And the advantages of having an IPv6 over an IPv4 is that IPv6 has less risk of IP address collision, which means that every IP address is going to be unique because we have such a large range of having unique IP addresses. Then it also has built-in authentication checks to ensure that everything is perfectly fine, and it allows a better efficient packet routes, which means that it is allowing us to have the data transferred even in a much faster way. Here's a table which basically summarizes the whole differences. MAC address identifies the physical address of a device on a network, whereas IP address identifies the global address. This is unique, this might not be unique. Your MAC address, that is assigned by the NIC. IP address is usually assigned by your internet service provider, which means that whenever you connect to a network, the network is going to assign it to you. Okay, IPv4 makes use of denary. Yes, it does. Then your MAC address could be universal or local. IP address could be either dynamic or there could be static IP address. वो इसके बाद we're going to study. Okay, what is MAC address? Apart from that is that when a packet of data is received, the MAC address is basically used to identify the senders and recipients' devices. But IP address on the other end is then used in routing operation, like where do I need to send the data, where do I need to send the data, where do I need to send the data. Your MAC address uses 48 bits, whereas IP address uses 32 or 128 bits. And MAC address could be UAA and IP address could be static or dynamic. Now let's see what static or dynamic is. So static IP address is the one which stays permanent. Okay, whereas dynamic address is something which is temporary. So for instance, this is my dynamic one. What happens is, let's say you might want to so what happens is if let's say the dynamic IP address is the one which whenever you try to jump onto a network, it changes always. Static one is the one which stays the same always. Okay, so it never changes. So now if a question comes up in your exam that if you want to access a specific server, past paper ho jayenge guys, ho jayenge. So if ever in exam they ask you a question which says that how are you going to access a specific website server, the logic to that is that when you want to search for some website like www.google.com, it's not like your computer understands what's google.com. Your computer needs its IP address to access its server. So what happens is that when we write this www.google.com, the browser takes us to a place known as DNS, or the domain name server. The domain name server is basically a place where we have the domain name. This is my domain, google.com, and then we have its corresponding IP address. So it looks for that specific IP address, and if we for the specific domain, and if we let's say found that domain up there, we're going to return the IP address to the user. So I found google.com, I'm going to return its IP address to the user, and now this IP address is then going to be used for the person to basically access the web server. And now when you access the web server using their IP address, whatever data is up there you get downloaded, that comes to your computer, and then your browser interprets it. Okay, apart from that, one other important point to note is that before everything like this happens, it's really important that your computer also has an IP address, right? Your computer also needs to have some network identification. For that, whenever you temporarily connect to a network which assigns you a dynamic IP, the dynamic IP is assigned to you something like through dynamic host configuration protocol, which is known as DHCP. So whenever your device makes a request for an IP address, let's say you connected with your friend's PTCL broadband, so your computer or your mobile or any device, that's going to send a request to the DHCP. It's going to send a request, it's going to say that, okay bro, can you please send me the IP address or assign me some IP address. So the DHCP server is then going to assign an IP address, and then that IP address is going to come to the device, and then using that IP address the server is going to be accessed. Okay, moving on. So Lahore is greater than Peshawar. Bro, nothing in this world can beat Peshawar's food. Okay, nothing. I'm telling you, nothing in this world can beat Peshawar's food. I'm telling you, like there is no comparison between Peshawar's food and this Lahore food. I'm currently at Lams, and to be honest, Lahore disappointed me with their foods. Promise. Coming to the static IP one, the static IP address is the one where you have a permanently assigned IP address. So like I have a device and it has a permanently assigned IP address. Wherever I go, whenever I go, the IP address never changes at all. So yeah, so the static IP address what happens is this is something used usually by your databases or by servers, where we don't want the IP address to change every time. Okay, so we basically go to a domain name server, we basically have a static IP address assigned to it. Okay, so we say that you have a set IP address, this will never be changed, and then based upon that you go to a specific DNS, you search for the domain, you get their IP address, then you search for that IP address, you get the web data on that server, you download them, and then you can access that website on a web browser. Here's are a few differences. The IP address for static does not change, whereas dynamic, they changes every time. So dynamic one is a bit more private and it's more secure in regards to your public one, because the static one is openly available. Okay. And static IP address is way more faster too, but of course at the same time it's very expensive. And the last part of the syllabus is that we have something known as routers. What's a router? It's that specific component which we call as a modem, which allows the data packets to be rerouted from one network to another. So we have two types of area networks. One is known as the local area network. Local area network refers to the area which is within that router. So like if I have a PDCL device, and that PDCL device has my PC connected to it, laptop connected to it, my phone connected to it. So this model or this connection which is between everything within my home, only within my home, okay, within the specific network interval, that's known as local area network. But remember, every local area network, this router is then going to go out, it's going to connect with another local area network, that is going to connect with another local area network. We saw this in the chapter number 2 where the data packets were basically transmitted using different sort of nodes. Remember, we had data packets going from one node to another and another. So it's basically all of those nodes were one local area network, and every local area network is then connected to another local area network. And when I simplify this whole thing, where we have multiple local area networks connected at once with each other, it forms a wide area network. Okay, so the way it happens is that these local area networks, or what this router generally does is that a router is that device which basically converts the data coming from a local area network into a format or a protocol which my computer network can understand. Now in my computer network, if I, let's say, want to further extend, like let's say I had a broadband at the top floor, but it's not, the signals are not coming to the ground floor, so I can have an extender installed too. That extender is given the name of a switch. Okay, so what happens is this switch and router, they basically convert the data coming from the local area network and from the internet into a format and protocol which is then understood by computer. And this is the last point of the syllabus, that broadband routers, they basically sit behind a firewall, and the firewall protects the computers on a network. The router's main function is to transmit internet and transmission protocols between two networks and allow private networks to be connected together. And what this router does is, the router basically, they inspect data packages sent to from any computer. So every computer has an IP address. The router, based upon that IP address, sends the data to its appropriate switch. So I would be like, okay, a router is like, okay bro, do I need to send the data to the computers in the upper floor hall or in the lower floor hall? We have another extender there and another extender up here. So it's going to look onto the IP address. It's going to see that, okay, the extender where I need to send the data, it has to be the upper one. So it's going to go to the upper one, and from there it's going to send it to the corresponding computer. Okay, and let's say is able to be then sent to the appropriate switch. And then once it comes to that point, once it comes to that location where I know now that the data needs to be sent to one of the three devices in the upper floor, let's say in my house is upper floor, then to distinguish between which device it needs to be sent, that will be done using the MAC address. So it's going to then check the MAC address, and based upon that MAC address, it's then going to be sending the data. So your routers could be wired and it could be wireless devices, and boom, there you go. Congratulations, you have completed chapter number 3. Oh, that was crazy. GG's. I haven't been to Karachi, so I cannot say anything. IC is pre-installed by manufacturer. What do you mean by IC and IS? Write the full form. Is MAC address same as IMEI? No, it's not the same. IMEI is basically a unique identification number which is assigned to your computer or to your mobile device based upon the SIM slot. So it's a unique SIM slot identification number. A MAC address is something different. Is UAA and LAA in the syllabus? I guess it's not in the syllabus. MAC address is your device ka number. You can sort of say it that way. Yes. NIC is pre-installed. NIC is something which whenever you want to create a computer, it needs to be within it. So it's like pre-installed by the manufacturer. Any device having Wi-Fi capability will have a NIC inside it. Okay. Sir, what is the major issue with the app Plums Me? Bro, I did not get your question. Sir, do I need to do? Yes, you need to do everything. Which college says? So I did my A levels from Roots, and right now I'm a freshman at LUMS. 3.3 be done and 3.4 be done. Sir, we no need to know in-depth details about defragmentation. You should know what defragmentation does. So like a 3-marker question can come up on what does a defragmentation software do. Okay. So, sir, can I score an A without knowing pseudocode? हाय क्या सवाल पूछे, क्या सवाल पूछे. Good one. Yes, I'm a Pathan. Yes, I am. Sir, how much marks do we need to get an A star? So if you're scoring anywhere around 115 to 120 plus, ideally if you're 120 plus, you're good to go for an A star, inshallah. And if you're scoring 100 plus, that's like a good chance for an A. Even at times 95 plus is an A too. Okay, so guys, we're gonna do topicals. Okay, we're gonna do topicals. So we're gonna do topicals, but I'm gonna take a 7 minutes break. Okay, just a 7 minutes break. So we're gonna come back at 11:35, and then we're gonna do topicals for chapter number 1 only, and then we can do topicals for the other topic later on. So yeah, how long the topicals? I don't know. Maybe we might go till 12:15ish. 12:20. So we're gonna do topicals. Okay, so a break for now. See you guys inshallah afterwards. Alright, we are back, and let me just turn on the chat box. Alright, guys, back to the content. Am I audible? On the chat box. Yeah, let's go, let's get back to the content, let's get back. Yep, we're gonna do topicals right now. We're gonna do topicals. Don't worry, bro, topicals hi karenge. Easy scene. So, let's start off with the topicals. Let me just load up another booklet. Let's just bring up this practice booklet one. I don't know what I was doing up here though. But yeah, I'm gonna be pasting some questions from topic number 1, and then we're gonna solve them together, okay? So we're gonna start off with the summer 2024 paper. I'm gonna do the summer 24 papers first, and then we're gonna move on to the Feb March 24 papers, and then slowly we're gonna see how each question needs to be solved, okay? So just give me a minute. Alright, so we're gonna do questions from topic number 1. I'm gonna first and foremost try to do some of the questions which are being frequently tested, so that you get to know the general concept of how to do them, and then afterwards we're basically going to do some complex questions too. So if anybody has some questions about how to calculate the file size and all that stuff, don't worry, everything will be inshallah addressed today. So this is the first question which we are going to do. This is from May June 2024. Okay, let's start off. Anywhere, if you don't get anything, you can stop me and let's see. So it says that the binary number 10100011 is stored in RAM, and that a logical left shift of 3 places is performed on the binary number. Okay, so a logical left shift basically means that the value at the extreme left hand side, it's being transmitted to one another left hand side. So it now says that you need to give us the binary number after the shift has taken thrice. So how do you do it? So my advice to all the students who were part of my batch was that you first and foremost write the number clearly, okay? And for every logical shift, this basically means that you take every digit and you take it to one left hand side. Okay, I do see the chat, okay? So you take one digit and you bring it to the left hand side. So by taking it to the left hand side, this means that this one is going to come up here, this 0, or perhaps if I have to make it something like this, just know that if I have to copy everything to the left, it's just going to follow this order, that this 0 is going to come up here, this 0 comes up here, this one comes up here, this one comes up here. But now there, where does this one go? That should be a question, right? So remember this, whenever you're asked for the binary shift, this operates some similar to like a cliff. This one, it's like at the very end of the cliff, so it just jumps off and boom, we have to ignore it. So the most left hand side bit in a logical left shift is then deleted, and we see that an empty bit has been created at the end which has nothing. So this empty bit at the end is then going to be assigned the value of 0. This just happened as a logical shift on the left hand side once, but the question says that you need to do logical left shift 3 times. You have to do it 3 times. So you have to do it 3 times. You need to repeat the whole process again. So next time 0 is going to be vanished. So 1 comes up here and everything repeats. 0, then 1, 1, and then this 0 comes up here, and then we have another 0. Then again, the whole process again repeats. This 1 vanishes. So 0 takes its place. This 0 comes up here. This 0 comes up here. This 1 comes up here. This 1 comes up here. This 0 comes up here. This 0 comes up here. And I have a 0 again. So the final answer for this part basically comes out to be as 0, 0, 0. 1 1 0 0 0. Part B now says that you need to tick one box to share which statement about logical left shift of 2 places is correct. Now remember, every logical shift towards the left hand side basically multiplies the value by 2. And every logical shift towards the right hand side, this basically divides the value by 2. Now if a value has been shifted once, the value has been multiplied by 2. If the value has been shifted twice, this basically means that you multiply it by 2 once, then you again multiply that by 1, which makes it 2 into 2 as 4. So it would basically multiply the binary number by 4. Therefore the answer is D. Part C now says that this number 1010011 can be stored as a 2's complement integer, and that you need to convert the 2's complement integer to denary. So whenever you hear the 2's complement integer word, remember one thing: there is going to be one additional element, and that additional element is that the most significant bit means the most left side bit. That most left side bit will be having a negative value. In our case, mostly it's going to be a 8-bit integer binary value. So it's going to be something like, if I have to write the values, it has to be 1, 2, 4, 8, 16, 32, 64. But because it's a 2's complement integer, it won't be 128. It has to be minus 128. That's a characteristic or a feature of the 2's complement number. Okay. And now when we see something like this, now I have to just write 1 beneath them. 1, 0, 1, 0, 0, 0, 1, 1. And I need to basically add the values to see what my final answer is. So a tip for this is that rather than doing it this way, you need to first evaluate it. It has been minus 128 plus what? 32 plus 2 is 34 plus 1, 35. So I get 35 from here. Okay. And now, if anybody does not know how to do this, a proper easier method is that you subtract the values and just put minus with it. So it's similar to saying that I take minus common and then it becomes 128 minus 35, and then I find this answer, which is like 128 minus 35. This comes out to be 3 and this comes out to be as 9. Am I doing it wrong? Why is it 85? Did I miss anything? Minus 128 plus 32 plus 2 plus 1. This should be 34 plus 1. Yeah, I'm correct. So it should be 128 minus 35. So this 5 is going to go down 3, and 12 minus 3 is 9. So my answer is basically minus with bracket 93. And so when you multiply this, I get my final answer to be as minus 23. Now guys, the answer which you guys gave me right now, 85 minus 85, that's the blunder you're going to make in exam. You guys think you know the concept. Well, you do, but you rush it. And then you make a silly mistake like this. So imagine losing 2 marks in paper number 1 from such an easy question, just because you wanted to become Tismar Khan and you wanted to become that person jo paper jaldi karke hall se nikal sake. Okay, so you should know that these subjects clearly mention in the syllabus that you are required to know all these mathematical calculations. So it's not like you are being tested, it's like you are required to know all this. This is compulsory for you. Okay, part D now says that the binary number is measured as a byte because it has 8 bits. State how many bytes are there in kibibyte. So remember, if I have to quickly make a diagram for you, 8 bits are basically equal to 1 byte. Okay, then 1024 bytes is basically equal to 1 kibibyte. Then so on, 1024 kibibyte is basically equal to 1 megabyte, and then this process goes on. One important thing a lot of people never understand is that 4 bits is basically equal to 1 nibble. This is one thing a lot of people don't know. So this question asks you how many bytes are there in a kibibyte. So we clearly know that in a kibibyte, which is this, we have 1024 bytes. So I'm just going to write what? I'm going to write 1024 bytes, or perhaps 1024, and boom, there you go. We are done with the first question. So now I'm going to paste another question. Let me see if I have a question from this paper. Otherwise, let's go to the next one. Alright, perfect. We don't. Okay, let's do this now. So I'm going to paste this. Okay, that's a good question. Question number 1. So this question says that the size of a file can be measured in different units. State how many bits there are in a byte. Pretty much very straightforward. We all are well aware that there are basically 8 bits in a byte. Then the second question says state how many kibibytes there are in 2 megabytes. So the diagram which we just drew, I know that 1 megabyte is equal to how many kibibyte? 1 megabyte is equal to 1024 kibibytes. So now if I have 2 megabytes, how much kibibyte will those be equal to? They will be basically 2048 kibibytes. How did I get that? So I just multiplied this by 2. So 1024 multiplied by 2. 4 2s are 8, 2 2s are 4, 2 zeros are 0, and 2 1s are 2. So that's 2048. And therefore the answer to part B is basically 2048 kibibytes. Part C now says identify the unit of data that is equal to 4 bits. See, the same thing which I said a lot of people won't know. It is what? It's a nibble. So 4 bits is equal to a nibble. Therefore, for C, you are going to write the answer as nibble. Clear? Perfect. Then we see that there should be a question another up here. So we do have this question where it's just converting the values, but okay, let's do this. This is a good question. So let me just take the screenshot of it and paste it up for you. So this is the first part. I'm gonna do this all together. Oh, my bad. So yeah. Oh, so that's the first part of it. It says that a programmer is creating a game. Perhaps let me also paste the second part of it, and then we can do it together. Alright, let's do it now. Perfect. Back to the content. So it now says that a programmer is creating a computer game and that one character is not moving correctly. Okay, that's perfectly fine. Then it says that the programmer needs to debug the program. To do this, they basically need to look at the addresses that are locations in memory. Now, one address is A to F. By seeing A to F, what comes into your mind? It basically tells us that A to F needs to be a hexadecimal value. So I know that this A to F is hexadecimal, and if I have to go from hexadecimal to binary, how do I do it? You always divide it into chunks. So you divide it in a way that if I have A to F, I'm going to find the binary of each of them separately. I know A is basically 10, B is basically 11, C is basically 12, D is basically 13, E is basically 14, and F is basically 15. So if I have A, this is 10, and if I have F, that's 15. So now I'm going to write the binary for each of them separately. 1248, 1248, and 1248. So what's the binary for A, which is 10? It has to be 8 plus 2, right? And the other two are going to be 0. What will it be for 2? That has to be 0, 0, 1, 0. What is it has to be for F, which is 15? All of them needs to be 1. So once I found it for all of them, I'm just going to combine them together, and boom, I'm going to get my answer as 1010, 0010, 1111. Then it says now you need to convert the address to denary. So if I have to convert it to denary, I'm going to write the values first: 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. And now I need to basically convert this address into this format. So let me just write it up. Till then, I also need to do one other thing. Just give me a minute. I forgot about that. Just a second. So I did not order any food for myself. So I also need to grab some food. So let me install the app for it. Alright, never mind. So now, how do you do it? You're just going to write the value beneath it. So 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1. Oh, 1, 2, 4, 8, 16, 64, 125. Okay, my bad. 2048. I forgot that. So it's going to be 2048. And so you get this all the way this way. Oh, my bad. So you have to rewrite it, I guess. But yeah. So we have 1 up here, then we have basically 0 up here, then we have a 1 up here, then we have a 0 up here, then we have a 0, 0, then we have a 1 up here, then we have a 0 up here, and all of them is basically 1. Now, I'm going to add the values where we have the value as 1. So all this, 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 and this. So how do I do that? First and foremost, let's do the smaller one. So it's basically 2048 plus 512 plus 32 plus 8, which is 40. 40 plus 4 is 44. 44 plus 2 is 46, and 46 plus 1 is 47. So now I'm going to add 512 and 47. That's going to come up as 7 plus 2 is 9, 4 plus 1 is 5, and 559. And now I'm going to add that into 2048. So 559 added into that is going to be 8 plus 9 is what? 2, and then 7. So 7 comes from here, then with 1 carry. Then 5 plus 5 is 0 with 1 carry. 1 plus 5 is 6, and 2 comes below, so 2607. That's my address. Okay, 2607. Moving on, part B now says that the binary number is a calculator allowed. No, your calculator is not allowed. Same. So part B now says that the binary number stored for another address is this, and you need to convert this into hexadecimal. So whenever you want to convert it into hexadecimal, the way you do it is you find groups of 4. Okay, so you find nibbles, you find groups of 4, and then you convert the respective nibble into the values. So like, let me do it for this. This is going to be 1248, this is going to be 1248, this is going to be 1248. So this first one is 1, so 1 comes directly, this makes it as 1. The value for this is what? It's basically 8 plus 1. 8 plus 1 is 9, so 9, just like this. And then we have this 8 plus 2 plus 1, so 8 plus 2 is 10, 10 plus 1 is 11, but we cannot write 11. How do I write 11? For that we have hexadecimal A as 10, B as 11. So I'm just going to write 11 up here. It's going to be 8 plus 2, 10, 10 plus 1 is 11. So therefore the answer is going to be 19B. Okay, 19B. Now a lot of you would be making this mistake, that because they would be like, okay, I know that 11 is C. 11 is C, and you're going to quickly write 19C, and boom, you're going to make that mistake. So it's not 19C, it's 19B. So that's my advice to everybody. Please listen up. Whenever a question for hexadecimal comes up, write it fully. Write it like literally fully, all the way till f equals to 15, like full form, so that you can understand it. Okay, and now it says convert the binary number to denary. So now again the same step. So I'm going to write the values. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048. And now I'm going to write the values beneath them. So it's just going to be 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1. So again I'm going to just do it for these two, for these two, for these two, and yeah. So how do I do it? So you're going to add them up. So it's going to be 256 plus 128 plus 16 plus 8 plus 2 plus 1. So again you might do it step by step. So 256 plus 128 is what? So if I add these two together, 8 plus 6 is basically 14. So 1 goes up there, 6, 5 plus 1 is 6, plus 2 is basically 8, and then 2 plus 1 is 3. So 384, and then 384, if I add this part basically is 384, and I need to add what? This is 16 plus 8, which is basically 24. 24 plus 2 is 26, plus 1, 27. So it's going to become as 384 plus 27, which again 7 plus 4 is 11, so 1 carry. 8 plus 1 is 9, 9 plus 2 is again 1 with 1 carry, and 3 plus 1 is 4. So I get my answer to be as 411, and therefore the answer is 411. If anybody wants to access the topicals, go and search for physics math tutor. Okay, physics math tutor. Open up their website, go to the Igcse CIE revision section. They'll select the computer science as the subject, and you're going to get a lot of topicals. Okay, a lot of topicals. So the answer for that reason is 411. Alright, let's move on. So to the next question. So just give me a minute. Alright, so the next part says give one reason why the addresses are basically displayed in hexadecimal instead of binary. So usually you always represent something as hexadecimal, because if I have a whole long binary number, reading that will be very challenging. So hexadecimal is easy, it can be easily memorized too, so I can say it is quicker to understand and read. And second point is that it takes less space on the screen. Okay, so it takes less space on the screen. So it's not like the whole screen is filled with numbers, no, a small chunk of it. So you don't say that it takes less space, that's wrong. You need to say that it takes less space on the screen. So it takes less space on the screen. So if you don't write on the screen point, it's going to be wrong. Why? Because space on what? In the storage, on the screen, somewhere else. You need to specify it clearly. Okay, and then the second point would be that it is easier to understand, or you can also write debug. Okay, that, or you can also write read. All three of them points are perfectly fine. And moving on, part D now says that identify two other ways that hexadecimals are used. So we have studied this in chapter number 1. Hexadecimals are used in your MAC addresses, it's used in your memory dumps, it's used in your HTML color code. You can write any of them, right? So you might write MAC address, because we just studied that, and you're gonna write something like maybe memory dumps, and done. Part E now says that the health value for a character in the computer's game can be sometimes be a negative value. and that the negative values are stored as 2's complement 8-bit integer. A character has a health value of minus 25. Calculate the 2's complement 8-bit integer for minus 25 and show all your working. How to do complex calculation? We're gonna come to that question, Mariam, don't worry, iske baad mein wahi kar raha hu, okay? So how do you do this? So for that, remember, whenever a question like this comes up, you basically need to first and foremost write the binary for positive 25. So you write the binary for positive 25, then you flip the bits, you add 1, and that gets you your answer. So for example, if I have to solve this question, I need to first find the binary 1 2 4 8 16 32 64 128. You're going to have first and foremost, you're going to find the binary for positive 25. That's going to be 0 0 0. 16 plus 8 is what? 16 plus 8 is 24, and 24 plus 1 is 25. So this is my binary for positive 25. Now what I'm going to do is I'm basically going to swap it, or basically flip the bits. When I flip the bits, it's going to make it something like 1 1 1 0 0 1 1 0, which basically means that you make the 1 a 0 and the 0 and 1. So this step where you flip it, this is known as 1's complement. You should know this, okay? This step where you basically flip the bits, that's known as 1's complement. And whenever you add value of 1, when you add the value 1 into a 1's complement answer, the answer which you get, that is of 2's complement. So 0 plus 1 is 1, 1 plus nothing is basically, this is all 0 below this, okay? So all this is 0. So 1 plus 0 is 1, 1 plus 0 is 1, 0 0 1 1 1, and that's my answer for negative 25. Okay, so we have a question that said, if I memorize all the marking schemes of Topical, what grade could I get? You would be able to ace your paper number 1 to a great extent, and so yeah, we have a question up here. So you say that I did the past papers of IGCSE, those में the working थी तो याद करेंगे. So by the way, just for everybody who might not be aware of this, you're working for like the syllabus for IGCSE and your syllabus for your O level, they're 100% same. Okay, so there is no difference whether you do the IGCSE paper or the O level paper. Even the exact same question which is going to come up, that's also same. Sorry for the background noise, a few friends came in, but yeah, see. So that's your final answer for minus 25. And that's how you represent your 2's complement numbers. Sir, O level को input by सबको O level and IGCSE has the same thing. Okay, so किसी को याद नहीं करनी. Okay, so sir, if I memorize all the markings, हाँ हो जाएगा inshallah, good extent. Should we do topicals at this point? Yes, you should do topicals, not yearlies. Sir, can we do shortcut method where we simply subtract the any number asked in question by minus 120 and find any of that? You see this one thing? It says show all your working. They have the marks for you to basically find it for positive 25. They have the marks for you to calculate the 1's complement and then adding the 1 inside it. So if you make use of that, what do we call it? Where did Sir Suleiman come from? Sir Suleiman kidhar aaye? I didn't see that. But yeah, never mind. Yeah, so these 1's complement, this conversion, adding of 1, you have marks for this. Okay, so yeah. Sir, why not yearlies? Yearlies, इसलिए because at this point you should focus upon your weaker parts. Okay, so the more you do topic wise questions, you're going to find questions which haven't been tested at all. So solving those will help you understand the concepts even much better. Okay, and that will allow you to have a better grade. And at this point you have done enough papers, so no need to grind those. Alright, let's move on. We are done with this question too. Now I'm going to bring up a paper which had a file size calculation question. Okay, so we're going to solve a file size calculation question together, inshallah. So let's do this one question. Okay, so this is a really good question and I'm going to solve it using 2 ways. I hope after these 2 ways you would be clear with how to solve the question. Okay, so the first question says that you need to give the name of the data storage measurement that is basically equal to 1024 gigabytes. So what's equal to 1024 gigabytes? So the way we had the pattern coming up, it's just going to continue. Okay, so we had 1024 megabytes, so now 1024 megabytes is going to become 1 gigabyte, and then 1024 gigabyte, remember, is going to become 1 pbyte. Okay, it's going to become 1 PB byte. So when you want to basically find the PB byte value, it's basically you should know that 1024 GB bytes is equal to 1 PB byte. Moving on, part D now says that there is a 16-bit color image which has a resolution of 512 pixels wide by 512 pixels high. Calculate the file size of this image in KB bytes. Now the way you need to calculate the file size is that you need to multiply the resolution, so it's going to be 512 into 512, okay? Then this resolution needs to be multiplied with your color bit, which is 16. Now till this point I know you all would be like, oh my bad, I got it wrong. It's not PB byte, it has to be TB byte. Yeah, you guys are correct. It's 1024 TB byte. Correct. Happy birthday, Ghost the Rusher. But yeah, 512 into 512 into 16. This is basically going to give me the answer in bits. But the question asks me the answer in KB byte. Now, whenever a question like this comes up, you need to write all the calculations at once, and you're going to see that the values are getting cancelled off. So because it's in bits, I need to first and foremost go to byte. How do you go from bits to byte? You divide the value by 8. So if I divide this value by 8, this will give me the answer in bytes. Okay, so if I have to simplify it, I can see that this is 8 ones are, this is 2s are. So now my value has simplified. It's 512 into 512 into 2, but this, whatever this answer is, this is going to be in bytes. I need the answer in KB byte. Now if I want to go from bytes to KB byte, how will I do that? I'm going to divide that by 1024. So now if I divide this answer with 1024, I can clearly see that the values are being cancelled off. How? 512 one time is 1024 two times. Okay, 2 times. So you have now 512 multiplied by 2 divided by 2, and now 2 gets cancelled off with this 2, and you get the answer as 512, which is my answer up here, 512. There is one, however, another way too. When you are unable to simplify it using this logic, a better approach is that you can also do it in terms of power. So when I talk about in terms of power, by the fact that I am saying that in terms of power, it means that if I have to write the whole thing like the same 512 multiply by 512 multiply by 16, that first being divided by 8. So what if I convert all of this into 2 raised to power something? Like by the fact 2 raised to power, I mean that I know 2 raised to power 7 is basic, or perhaps 2 raised to power 8 is 256. We know 2 raised to power 9 is basically 512. We know 2 raised to power 10 is basically 1024. And we also know 2 raised to power 3 is 8, 2 raised to power 4 is 16. It's the same way we say like the position values 1, 2, 4, 8 and so on. So it's like 2 raised to power 1, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 and so on. Okay, so now if I have to convert this into powers, how will I write that? So what is 512? 512 is 2 raised to power 9, right? So I can write it as 2 raised to power 9 multiply by 512, again has to be 2 raised to power 9 multiply by 16. 16 is what? It's 2 raised to power 4. So I can write it as 2 raised to power 4. Then I'm dividing it with 8. 8 is what? It's 2 raised to power 3. So I can write it as 2 raised to power 3. Now the mathematical IGCSE O-level maths, you have studied this one concept that when you're multiplying values, the powers get add up, and when you're dividing them, the power gets subtracted. So now if I have to evaluate this, the powers are basically going to be added, right? So if I add the powers, it's going to make it what? 9 plus 9 is 18. 18 plus 4 is 22. So I get an answer as 2 raised to power 22, and then I have it being divided by 2 raised to power 3. This gives me the answer in bytes. Now if I have to evaluate this, because they are being divided, I'm just going to basically subtract the 2. So if I subtract the 2, 22 minus 3 is what? It's 19. So I get the answer as 2 raised to power 19 bytes. But I need the answer in KB byte, which means that I now need to divide this answer by 1024. Now if I have to divide this with 1024, what is 1024? That's 2 raised to power 10. So now if I do it that way, 2 raised to power 19 over 2 raised to power 10, again because they are being divided, I can literally just subtract their powers. So it's going to make it as 2 raised to power 19 minus the power 10, and that gives you 2 raised to power 9. Now what is 2 raised to power 9? I know 2 raised to power 9 is basically 512. So therefore my answer is basically 512, which is identical to the answer I found out through the cancellation method. Now either you want to go with the cancellation method, or you might want to go with the power method. Both of them are perfectly fine. I personally made use of this, but in this it's sometimes pretty complex to find out it for similar complex values. Therefore I would recommend going with this. You write the value this way, you convert everything into 2 raised to power format. Okay, then remember, whenever 2 raised to power x gets multiplied by 2 raised to power y, this is equal to 2 raised to power x plus y. And whenever you have something like 2 raised to power x divided by 2 raised to power y, like this could be different value, you could write it as 2 raised to power x minus y. So using this logic, you can simplify the whole model and you can get to the correct answer. And this method is way more easier. Why? Because you have studied this in your mathematics paper for your O level or Igcse. So making use of, if I'm not, this was indices, right? So if you make use of this indices logic, you would be very much good to go and you can easily ace your exam. Simple. Is this clear, everybody, or not? So you guys just need to give me 5 minutes, okay, just 5 minutes. I need to place an order for the food and then I'm gonna come back and then I'm gonna do a few more questions. Okay, so just give me 5 minutes. Alright everybody, we are back. The order is placed, alhamdulillah, and let's get back to it. The content, we're going to do a few more questions, maybe 3 or kar lenge, and then we can end the class. But yeah, that is how you generally have to solve such questions. Okay, so now let me grab one other question which might be similar to this. I'm going to go to the March series. I hope we have some question from March which is similar to this, and then we can have a look at that too. So did you do O level or IGCSE? I did my IGCSEs. One order for me too. Guys, A star leo phir khila dunga inshallah. Okay. What am I getting? Good question. I'm getting something really crazy. Really crazy. I'm getting something really crazy. More than you can think. So like, let me just eat it and I can share it with you guys tomorrow what I've ordered, okay? So because I don't want to talk about it before I have eaten it, nazar lag jati hai. Aisa maza hi na hai uska phir. So yeah, let the paper get loaded up and then we can start off with the next one. So yeah, is this method clear? That's how you generally calculate it, okay? So no, I ordered Brim. जॉनी जुगनू तो मैं रोज़ खा रहा हूँ, तो जॉनी जुगनू बस बहुत खा लिया. नॉट ईटिंग जॉनी जुगनू एनी मोर. सर बॉम्ब भी ऑर्डर किए. इट्स सॉर्ट ऑफ बॉम्ब बर्गरी. Why isn't the internet not working? Okay, so my internet has stopped working. Congratulations, very good. The paper, yeah, let's go. The paper loaded up. So let's do the next question from the March 2024 papers. We have done everything from the May-June session. So this is a good question though. I want you guys to just know this because this isn't tested that often. So you should be aware of this concept. Generally, if ever asked in exam, that what's a character set and how does the computer work alongside ASCII values. Okay, so the question says that the computer represents different data types of data in binary, and that you need to tick one box to show the reason why computer uses binary to represent the data. So what could be the potential answer? So if I can see that the first one says computer only allows 1 and 0s to be entered. No, that might be true, but no, you can enter anything else too, right? You might enter something like 10, 15, ABC and all that stuff, right? Part B is like computers are made up of switches and gates that can be only turned on and off. Yep, that's the correct reason. Part C says binary does not need to be converted. Nah. Both computers and human can quickly. No. So the answer to this is B basically. Part B now says that one form of data is characters, and that American Standard Code for Information Interchange, which is ASCII, the denary number for the character N is 78. Take one number to identify the ASCII denary number for Q. So you don't need to memorize it for all of them. The logic up here is that you need to see that after what value does Q come after N. So like A, B, C, D, E, A, B, C, D, A, B, C, D, E, F, G, H, I, J, K, L, M, N. It's N, O, P, Q. So if N is 78, O is going to be 79, P is going to be 80, and Q therefore is going to be 81. Therefore the answer to this question is A. So if ever a question like this comes up, that's how you need to do it. Now it says that you need to find the binary for the denary number 78. So it's pretty much easy. You just need to find the binary for 78. So 1, 2, 4, 8, 16, 32, 64, 128. So it's going to be 0. And the number is 78. So 64 plus basically 14. So this is going to be 0, 0. 8 plus 4 is 12. 12 plus 2 is 14. And that's my answer. So 0, 1, 0, 0, 1, 1, 1, 0. Clear? Moving on, part 3 now says explain how the word red is basically represented using a character set. So you should know that basically every character has a unique binary number. So like the code for R is stored, the code for E is stored, and then the code for D is stored. So like every time if I want to represent this RED in some plane or like in some text or somewhere, when I want to represent RED, I'm going to first write the code for R, then I'm going to write the code for E, then I'm going to write the code for D in a specific sequence, and my computer will then convert that code. And by code I mean like the R binary would be 0101, E would be 01101, D would be something else. So you're going to write the binary in one order and it's going to tell them. So I'm going to say that each character is going to have a unique binary value, and then the binary oh my bad so and then the binary value is written in the correct order, is basically you can write it that it basically is what do we call it, stored in the right sequence. So and then the binary value is stored for each character in the right sequence, stored for each character in the right sequence, and that will get you a perfect 2 by 2. Okay, so this was one question I want you all to do, just because I want you all to understand the concept behind it. And part C now says that let me paste the part C picture. That's also a good question, because such content are very rarely tested regarding sound and all. So this question says that sound can be represented as binary. Explain why recording sound with a higher sampling resolution basically creates a more accurate recording. Definitely, when you have a larger sampling resolution, you have more number of bits allocated for each amplitude, and when your amplitude is precise, this means a wider range of amplitudes could be recorded, which means that every small change in amplitude could be recorded, hence improving the quality. So I'm going to say is more number of bits could be allocated to each amplitude, and then you can say that once it has a more number of bits, you can talk about how then the amplitude could be more precise, and therefore amplitudes could be more precise, and a wider range of amplitudes could be recorded. Part 2 now says that you need to give one other way that the accuracy could be improved. So accuracy could also be improved if you increase the sample rate. So increase the sample rate. So one is sample rate and the other is sampling resolution. So if you even increase the sample rate, in that case you would still be good to go. Okay, and that is how you need to basically do this question. Moving on, let me see if I have some other questions from this topic. Otherwise, I'm going to look specifically for some file calculation questions, because I want you guys to practice those a bit. There was one question someone sent to me on my WhatsApp which I want you guys to solve. That was a pretty bad question, because that was one question which basically included a very complex calculation. Okay, this is a question which is something I'm not pasting the whole question because we did multiple similar questions before, so I'm just going to paste this one part of it. It says that logical shifts are performed on binary integers. State the mathematical effect of a right shift of 4 places. So we know that in this, when they talk about mathematical shifts, so variant 13 कर सकते, वो हमने कर ली है. We just did that. So right shift, we know that every logical right shift basically divides the value by 2. So if I divide the value by 2 4 times, what's going to be the answer? So this means 2 multiplied by 2 into 2 into 2. So you're dividing the value by 2 into 2 4, 4 into 2 8, 8 into 2 16. So you're dividing the value by 16. So you need to write the answer as the value will be divided by 8, by 16. So you're going to get 1 mark for 16 and 1 mark for the division part. Then you're going to get 2 by 2. Okay, that is how you're going to do it. The problem is chapter number 1 on its own is a bit easy. So the problem is with the question. So yeah, but never mind. Let me find something difficult. Let me see if I could find some difficult question. Let me see. There was one question a student sent to me which was having some complex calculation, and and okay, it wasn't this. Let me see, someone send it to me in my DMs. Try to find that question. So I'm unable to find the question, but never mind. I guess it was the October November. Let's do the October November 2023 paper, and then we can see if there was a question from there. Okay, so let's do the October November paper to see if something difficult pops up there. Okay, so sir, how to learn all values for TB bytes and table where powers are of 2. You need to memorize this. There is a table for this in your book. You can just open up that, or you can even view my notes. In my notes, if you check out the topic number 1 notes, in there you can find the what do we call it, corresponding value for like you're gonna get the table which has all the values for KB byte, MB byte, GB byte, PB byte, TB byte, XB byte too. Okay, so this one question is, again, this wasn't something we did, so let's do this. So this is from the binary addition topic. Okay, क्या कर रहे हो भाईजान? अहमद रियाज भाई, what happened? But yeah, let's do this one question. We did not do any binary addition question. Let's also try to do this so that we can cover up all types of questions, so that you know. Now after this you need to do the topicals on your own. Okay, this is just to ensure that you get all the concepts, and now you need to do topicals on your own. So if I have to add the two binary values, remember there are a few rules. The rules are that when you add 1 with 0, it's going to give you the result as 1 and the carry of 0. If you do 0 plus 1, again the result is going to be 1, carry is going to be 0. If you do 1 plus 1, it's going to be, the result is going to be 0, carry will be of 1. If you do 1, like 1 with the carry, plus 1, then that's going to be 1 result with 1 carry too. So let's try doing it. So it's basically 0 1 0 1 0 0 1 1 0 0 being added into 1 1 1 0 0 0 1 1. So if you add these values, you're going to get the answer as 1. 1 plus 0 is 1. 0 plus 1 is again 1. This logic. 1 plus 0, again similar logic. So 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0, oh I forgot that. 0 plus 0 is basically 0 with 0 carry. So 0 plus 0 is 0. 0 plus 1, again it's going to be 1. 1 plus 1 is going to be what? It's going to be 0 with 1 carry. And now I see that 1 plus 1 again is going to be 0 with 1 carry. Now do I leave this carry? No, I bring this carry and I write that down here. So now my final answer is basically 1 0 0 1 0 1 1 1. But this 1 which has been generated, this is outside the maximum capacity of the 8-bit register, which basically means that it's going to result in an overflow error. So you need to basically then clearly mention, perhaps even the next part of the question would be about overflow error. Let me even see where it's not, but yeah, if you add these values, it's going to result in an overflow error. Okay, so you need to solve this question this way. The chapter number 2 will be done tomorrow, inshallah. We're going to do every question which I can find, but I'm not finding any difficult question, unfortunately. I'm trying to look for difficult questions. Sir, do O-level have to practice IGV variant theorem? Yeah, you can. It's the same for all of them, okay? Let me try to see a question. Why don't we have some good questions, guys? I need to find some file calculation questions. Okay, we can do this one question, which is again from chapter number 1. And let's try to wrap it up with this then. I'm trying to just find one other question after this for file size calculation so that you can further master that up. But yeah, let's try solving this. This question is basically from your resolution and compression topic. So it says that first part says state what is meant by an image resolution. So image resolution basically refers to the total amount of pixels in the horizontal direction by the total number of pixels in the vertical direction. Okay, so you just need to write this description up here. Just give me a second. Yeah, so so it's basically the number of pixels, the number of let me zoom in. So the number of pixels in the high direction by the y direction. So high is basically vertical, whereas wide is basically your horizontal. And you can also write one other point up here, that image resolution is basically the dimensions of an image. So if you even write that, dimensions of an image, that's also perfectly fine. Dimensions of an image. Part B says what is meant by image color depth. So image color depth basically stands for the number of bits used to represent each color. So number of, you have to write full it, but I'm just trying to do it quickly, okay? Used to represent each color. Used to represent each color. Okay, Shayan, I can do that question. Okay, just a minute. Part C says state, give one benefit of increasing the color. Definitely, if I increase the color depth, I would have a greater range of colors. So a greater range of colors could be used or seen. A greater range of colors could be used or seen. Part D says that the photographer compresses the image using a method that permanently reduces. So if it's permanently, it has to be what type of compression? It has to be the lossy compression. If the question said that it was not permanent, then it would have been the lossless compression. Lossless compression is the one where you identify pattern. In lossy, you remove the part which we don't need. Part D says what are two benefits other than the fact that it reduces the storage space. So you have a lot of benefits. Firstly, you can quickly transmit it, okay? So then you can say that you will not require as much bandwidth to transmit a file, so like the internet power in simple words. So I can say quicker to transmit, and then the second could be a question point could be less bandwidth required to transmit the file. Quicker to transmit and upload kar do perhaps, okay, and less when required to transmit. And there we go, we are also done with this question. Clear? Perfect. Alright, so now let's try to do this one question. October, November. Shayan, can you tell me, is this 2024? Or are you talking about 2023? Less storage space will be incorrect, Huzefa. Why? Because read the question. The question says that point has already been mentioned. That question point has already been mentioned. Ahmed Shafi, I feel like आपको right shift and left shift की logic नहीं पता. So for that reason, आप एक काम करो. Let me tell you what to do. So just open up my YouTube channel. The moment you come to my channel, the first topic is about data representation. In that data representation, I am pasting this video for you, okay? So the moment you come, I'm going to explain, like the whole topic has been explained in great detail. So let me just paste it for you up here so that you understand what am I talking about. So when you open up my channel, the first playlist is this. Up here you can clearly see this playlist explains the whole topic in great detail. So it discusses the addition, and it also discusses your logical shifts. So you can just watch this and it's going to explain the whole concept, okay? A question is sent in the group. Can anybody of you kindly send that question to me in my DMs? Someone send it to me in my DMs so that I can solve it. So do I have to write carry in addition? You need to clearly show the carry. That's mandatory. So you need to at least show this one. So like if I'm adding something 1 0 and then you need to clearly show this one. This is mandatory, okay? So let's try to solve this one question of winter 23, which is paper number 11. Okay, so let's do this one question and then I'm cooked. After this I'm cooked, like literally bus. I've been taking the class for 2.5 hours at this point. So where are the notes? These notes are basically on my website. So you just open up my website and वहाँ पे आपको मिल जाएंगे. Winter 23 question paper 11 has no question. Paper number 11. It's not a file size calculation question though. Okay, so this first question is pretty good though, and perhaps that's a really good question. So I'm just going to take you guys through the question. Okay, I'm unable to write the whole thing, but yeah, let me just paste the question. I'm going to explain what to write inside that because I'm literally cooked at this point. So the first question says that a musician is basically recording herself playing the music for a song on the piano. Explain how the analog sound is recorded and converted into digital. So the process that this basically follows is, the process is that first and foremost, you record the sound using some microphone, right? So you're going to record the sound using the microphone one. Then once your voice has been recorded, you basically sample it. By sample, I mean that you find its amplitude. You find its amplitude, and based upon its amplitude, you assign it a unique binary value. Then you do this for the whole sample, so you like take multiple samples, or you can also say that a sample rate has been set up, and after that for each of the samples you're going to set a specific number of bits, which we call as the sampling resolution. And together, when you store the sample rate and sample resolution both in terms of binary, this allows the entire sound, which all the way I set from my microphone, to be converted into a binary value. Okay, that is everything you need to do. Is INB and modulo calculation important? No, no, no. If asked, the question will clearly give you. Okay, moving on. Part B of this question then says, let me paste both of the questions so that I can explain both of them at once. So question number 2 now says that basically state 2 ways that the accuracy of the recording could be increased. We did something similar. If you want to increase the accuracy of a recording, there are only 2 ways. Okay, only 2. One is that you increase the sample rate. The other is that you increase the sampling resolution. Again, talking about the fact that ADC is used, that is some point which if you want to add you can, but that's not the main question. The question mainly asks about how the analog sound is recorded and converted to digital, which basically means that they talk about how do you sample the sound. So sampling the sound is the main question up here. It's not that you need to basically talk about just microphone and ADC and boom. No, you need to talk about the sampling part. So how do you increase the accuracy? You increase the sample rate and you increase the sampling resolution. Part C now says that the musician compresses the sound file using lossless compression instead of lossy. Explain how will they use the lossless compression. So we know lossless compression does what? It's basically that compression in which if they want to edit the original source file, or what do we call it? What's the question? So it says explain why they would choose to use. Okay, so they say why will the person go with lossless compression instead of lossy. So the person would go with lossless because they don't want their file to be permanently destroyed, right? So maybe they might want to be able to edit the file later on. They might want the highest sound quality file. Okay, they like if you made use of lossy, this means that the sound quality would be loose. Why? Because some of the data would be permanently deleted, which would again mean that the data will not be able to recover. So that's one problem too. Therefore, the person would love to go with lossless. And the last question for this part for this question is that the musician types the words for the song into a document, and that 2 character sets that can be used when converting text to digital are the ASCII and Unicode. You just need to give them the differences. So that's an easy question. ASCII, remember, has limited characters in comparison to Unicode, which has way more. Also, ASCII has fewer languages in comparison to Unicode, which has way more languages. Then ASCII requires like 7 or 8 bits per character. If it's the normal ASCII, it's 7 bits. If it's the extended ASCII, it's 8 bits per character. But Unicode could have up to 16 or 32 bits per character, which allows your Unicode to have way more possibilities of words and way more languages in comparison to the normal ASCII. And that marks the end of this question. Boom. I'm cooked. By the way, this question which you are talking about, which you all have sent, is this the Feb March question? So I don't want to solve a Feb March question though, but let me see. Then I just click the photo. The dimension of the photo are 14 to 20 pixel, and the pixel resolution is given in hexadecimal. Okay. The bit depth of the picture is 1100 bits. Okay. Bit depth is given in binary. Okay, that's a really good question, by the way. But can the whole syllabus be covered in 4 hours? No, difficult. By the way, the problem is if it's the Feb March 2026 question, I cannot solve it because I'm not officially allowed to solve it. What you guys can do is you guys can try to see, but I will not be putting in my input because it's not legally allowed. But yeah, I can make you guys solve a similar question on something else. Okay, so have you okay, so if I have basically a question which works in a way, just give me a minute. So Ahmed Shafi, you know what so unfortunately, when you comment like this, you're just gonna get banned from the entire channel. So you'll now be able to no longer see this question. So yeah, that person has been permanently deleted. So please search change name, field solve. No, I cannot change name, I cannot solve this. Okay, it's against the guidelines, so sorry. But one question up here is that, let's say there is a question which says that there is a file size of, let's say, 200, what do we call it, the resolution is 200 into 512, and let's make it 256 perhaps, 256 into 512, and the bit color depth is basically, let's say it's basically 3 bytes. Now this question is really good. Okay, this is a really good question. The question which you sent, that's easy, that's not that difficult though. But yeah, if let's say it's just confusing you with the hexadecimal part, okay, but ab kar to nahi sakte. But now if I have to solve this question and find the file size of this, how will I do it? I'm going to multiply the resolution first, which is going to be 256 into 512. I need the answer in kilobytes. Okay, I need the answer in kilobytes. So I'm going to first multiply this. Then I'm going to multiply this with my color depth. Now usually this is something which everybody does. They always divide it by 8. Do I need to divide it by 8 up here? That's the question which you need to ask. Remember. The answer needs to be divided by 8 only when your color depth is in bits. If your color depth is in byte, the way we have up here, then when you multiply it by 3, the answer is automatically in bytes. Then you don't need to divide it by 8. This was a question which was tested once, and a lot of students, including me, made this mistake. Okay, and so now this is going to give me the answer in terms of bytes. Let's say that it's like 2 bytes perhaps, or let's keep it 3. Okay, and now if I have to basically, let's make it 2 just to simplify the process. Okay, so we have 2 up here. So, and now if I have to go from bytes to kilobytes, I'm going to divide that with 1024. So one way of doing it is that you basically simplify it easily, like 512 is 1024, 2 and 2 gets cut off, and I might get my answer as 256 kilobyte. Another method is that I convert each of them to the power logic. So I know the powers, 2 raised to power 8 is 256, 2 raised to power 9 is 512, 2 raised to power 10 is basically 1024. So using this notation, I can see that this is going to be converted into 2 raised to power 8 into 2 raised to power 9 into 2 raised to power 1, and that is being divided by 2 raised to power 10. Now first you add all of them, so it's going to become what? 9 plus 1 is 10 plus 18, so it's going to make it 18, and then you divide it by 2 raised to power 10. Now if you subtract the 2, you can clearly see that this is going to become 218 minus 10, which is basically going to be 2 raised to power 8, that is 256. Now the point here to understand is, that we always divide this value by 8, because we say that the answer we got up here, that is in bits. Why do we get the answer in bits? Because the color depth is in bits. So if ever the question mentions that the color depth is in bytes, then you do not need to divide it by 8 to convert the bits into bytes, because when you multiply the resolution with something which already is in bytes, the answer you're going to get will automatically be in bytes too. And because that's automatically going to be in bytes, you're just going to divide it with 1024. This is something you should be aware of. This is really important. People mess this up. Now keep this in your mind, okay? Why is the food taking? It has to take a lot of time. It's a big order. But yeah, that marks the end of our today's class. I'm absolutely cooked at this point. 2 hours and 45 minutes worth of class. That's back to back 3 hours. By itna to मैंने पूरे दिन में पढ़ा नहीं होगा जितने आप लोग को पढ़ा दिया आज. But yeah, I hope this session was helpful and that you guys got something to learn, and that now you all understand that if a question of file size comes up, how you need to simplify it, or how you need to convert it into 2 raised to power something and then solve it that way. That is it for today. Was this session helpful? If it was, I would appreciate if you guys could drop your feedback on my WhatsApp. I would love to see what you guys think and all. So yeah, sir, I wanted to ask, if someone scores really good in marks in P1, like around 70, but in P2 40s mein marks aate hain, to will the P1 cover P2 or not? So if you score like 70 in P1 and you score like 40s in P2, that's like a confirmed A, by the way, inshallah. And if you, let's say, score somewhat around 45 to 50 marks, and let's say you score 70 in P1 and you are close to that 50 mark range in paper number 2, you can even get an A star. Clear? Alright guys, that's it for today. Then take care everybody. See you guys again tomorrow. Tomorrow's class will again be scheduled at the same timings. Okay, so I might not be free apart from that, or perhaps no, let's do one thing. Tomorrow's class will be scheduled at, let's schedule it at 4 p.m. Okay, so tomorrow we're gonna do topicals and all that stuff. Tomorrow's class will be scheduled at 4 p.m. So we're gonna have a class from 4 p.m. till 6 p.m. Keep this in your mind. Tomorrow's class, tomorrow's class, not for a distinction, for an A star. For a distinction you should aim to score a perfect 150 or 150 or like max 149. That should be the aim. Again, distinction does not mean necessarily full, but yeah, that's it. Okay, then that's it for today, everybody. See you guys inshallah tomorrow at 4 p.m. Share this with your friends too, let everybody know too, but take care. Tomorrow we're going to do the practice questions for chapter number 2, and we're going to try to do some practice questions for chapter number 3 too. So we're going to do topical only tomorrow. Take care, everybody. You guys can revise my notes. The notes are available on my website. Just open up my website, and I have uploaded a reel on my Instagram which explains how it works. If you haven't followed up my Instagram, do follow it up. We share a lot of useful stuff up there, and up there you can have a look at the reel. I uploaded it on my story as to how you can access the notes from my website. And that is it for today. Take care, everybody. See you guys inshallah tomorrow. Allah Hafiz, Allah Hafiz, Allah Hafiz.